some money that we learned in the beginning talk. So if the money finished, we're going to add a little bit more. But we thought that the key is going to be dropped after this talk. So it's going to be available only during the talk. Let's quickly introduce ourselves. So my name is Stefan, and I'm currently engineering manager at Radu. Also, I'm an architect, and I'm also doing a lot of stuff, especially in Java. So, do you want to introduce yourself?
Yeah, sure. So, Lugo here. Stefan and I are actually working together for almost a year now.
Is that right?
Yep, that one's yours. So, he's the core trading guy, I'm the everything else guy. So, I have all of the satellite projects around the core trading. And it's interesting to know that we've actually not written a single one of the code by hand since we started. I've done a lot of different things over the years, so let's just keep moving.
Yeah, so the funny story is that one day, one our tribe architect come to us and say, okay, I built that without touching and writing anything. And we were in fashion, are you kidding with us? How you do that? And basically present that code to us. And we were so surprised that this is really working. So we have code trading system which is designed the best possible way in the market based on all conference that I watched, and it's working. And basically it's written by Qualcomm, following those patterns that we're going to discuss today. What is this workshop is all about? It's not just a talk. It's basically presenting our flow, and we can do something together. So there was a document called PRD that is written by code, especially. So everything is written by AI those days. So we're going to go over that document. We're going to try to understand and see what the document looks like, and in which cases that is going to work, in which cases it's not going to work. Because if everything is documented in the one PRD file, we're going to enter something called waterfall. Yeah, we don't want to be in those stage anymore. So
a PRD is not a PRD if it's 200 pages long.
Yeah, should be something focused that could be delivered in around the spring, or maybe two. And something else that we need to speak here. So the question is what the agent could do without us, and what the agent couldn't do without us. So we need to be there. Without the human, there is not going to be a problem. So we're not vibe coding. We're doing a programming which is followed by our instructions. So we are experts in those domains, or at least we want to be experts in those domains, and we provide our context in order to build that. So this is what we are doing. What we're going to do. So we're going to go over a marked out file called cloud, which in our case is just a Java webhook receive project, and we're going to update that, look at what is there, what should be there, what kind of information we need to put in that cloud MD file. Do we need to put everything inside it or no? We are going to see. Also, we're going to see in which cases the agent should ask us. Yeah, that's the most important piece. In which cases the agent should stop working, ask us a questions, or we can ask a question back to the agent and see how we are going to move after that. What about scenarios? What is our PLD? So there was a woman called Maria. It's a payment PM. So somebody who understands the domain. At least we are hoping that the PMs are always understanding the domain, so they can provide us a document which describes what we need to do. And they have integration with a system called PayHub. It's not something else that sounds similar to that. It's PayHub. So, and something is broken there. We're not receiving webhooks. There were some payments that are not correctly summarized in our system. So everything is a big mess. And the PM is wrote out how that system should work in all of our cases, or at least how it's supposed to. And the main point is that the PLD is not contain any technical information. It's contain a business idea. It contains some functional and non-functional requirements. And everything else, it's up to us. So it's only business-related topics. Okay, and what else we're going to do? We're going to provide the entire context to the crowd code. And the crowd code is going to do the rest. Okay, about the architectures. So we need to decide a couple of stuff when we start doing every project. We need to decide our technology stack. So if we put everything to be decided by agents, we'll not know which technology is going to be chosen. And that's a big problem. So we're hiring very expert Java developers, so if our product is written by language like C#, it's going to be a mess. So we want to know which language, which technologies are going to be chosen for particular cases. Also, we want to use different technologies for different scenarios. For example, if we need to be fast, probably we're not going to use Spring. If we're going to have some case like just REST, just WebSockets, or something like that, Spring is good technology, probably. Not Kafka, Spring. So Spring is very good in those cases.
He mentioned Kafka.
Yeah, I did that because of Georgie. What is the agenda for this talk? So first, we introduced ourselves already. We're going to walk you over the PRD. We're going to see how QuartMD looks like, and we're going to start with you to build that feature. We're hoping at the end of this talk, the feature is going to work, or at least the big part of it, and you can try to finish it in your home, or during the working hours when you work.
But the main takeaway is going to be taking away the process, the patterns we've worked to establish for about a year. That sort of work even in regulated finance. So these are the lessons, quote unquote.
Okay, so let's move. Human in the loop bit. So where we are storing our events, where we are storing our metadata. Because, you know, the context is short. It's around 1 million tokens, nothing else. We need to store our context somewhere. We need to keep track of all of our decisions in the system. And we need to know in which file, what kind of information. We're not going to be able to read everything and put it back to the context, because we're limiting on that. Also something that I really hate when I was an architect, so building architecture decision records. So writing that by hand, it's very boring story. So we're going to use Qualcode and our architect agent to do that for us and basically get all the benefits of those documents. But also we need to find where to store them. In the most of the book from the architects, there was a repository with a bunch of those documents, but we need to keep everything close to the code. Why? Because the agents have access to the repositories and they want to get everything from one single place. So we're going to keep all of our Markdown files in the same place where our code is, in order to make them available for our Qualcode? Yeah, for Qualcode to read them, understand them, and help us to deliver our features. Okay, I think, Rubo, it's your turn.
Yeah, all right. So here's the main takeaway. One of the big issues we found was if you let a single generalist agent do all of the work, you get a regression to the mean, you get a lot of decisions that become implicit rather than explicit with a human in the loop, and you get basically something that's subpar. So that's also sort of the reason why we went with the idea of a cast, like different agents specialized in different things. It's not nothing revolutionary. We've just been doing it for about 9-10 months now, and we've been iterating on, I think, a roster of about probably 100 at this point in time in our day-to-day work. The roster here is a bit more limited, but we are also using it to illustrate the point, which is if you add agents, that's just a very, very small lens on top of a very big pyramid. But it still helps. It's still a lever that you can pull to make it specialized. And if you put sufficiently well-defined boundaries around it, what you get as output is a more honest system rather than something that's just, you know, in theory less capable and limited. And we do have a small roster, like I say here, but let me try to illustrate what I mean when I say well-defined boundaries. So it's not just the titles. Obviously, this is the idea of the development team, split in several MD or YAML files, depends on what you use. Let's start with the product owner. He's going to be the one who's going to be helping us figure out if the PRD is actually any good. So Maria has given us something. We're developers. We don't know what we're expecting from that PRD, right?
Yeah, let's ask the question to the people here. How many of you guys are getting the PRD documents or the requirements, which it's always correct, always written well, and everything is clear from the first time when you read those documents? Raise your hand. Somebody? At least one. Okay, George is raising hand, so probably it's working in a different company than me. Unfortunately not. But the case is that the business guys are never going to give you the document which is clear and represent everything that you need to know about the feature. That's not going to happen. Or at least I know only one PM could do that in my entire life. So yeah, continue please, sorry.
So here's the specialization. They analyze the functional requirements. They read, try to understand, they discuss, they brainstorm with us. They don't care about any of the rest. One notable highlight, the solution architect. He's read-only, he doesn't write the code, but he's the guy who's going to be putting the line in the sand about which decision can be made. And he's the guy who the backend developer or the QA engineer or the DevOps engineer is going to ping if they need to make a decision. So the specialization and the roles and the boundaries and even the tool access is what you need to define to actually be able to execute on a couple of loops that we'll get to later.
Just a question, can they communicate between each other?
Yes, so whatever you use as a harness, Cloud Code supports native teams. Like that's what we're using today for just, because it's the path of least resistance basically. But during a feature execution, they can communicate with each other. The agents themselves can't actually raise and block and stop stuff. They are advisors. The commands are going to be owning the blocks and the quality gates. We'll get to that in just a minute. Let me just highlight that all of these agents, and this is why it's actually a system rather than a random assembly of files, they have refusal points. So things that they say they will not do, basically when they throw the exception, right? We have the escalation paths, ergo to which agent the agent is going to escalate the issue. The project rules that we define in CloudMD are going to be something that they never subvert, in theory, because this is an LLM. Then we also have discipline, we have evidence. We try to make this as deterministic as possible, even though it's, like I said, a very small lens on top of a very big thing. So the major thing we want actually out of this particular system is that the human in the loop discipline is never broken. When a human is required to make a decision, it has to be raised. So that's the outcome we desire. And here's the pipeline we have to actually make that possible. So if you think about it, at each and every stage of this, so let me just, probably don't see it at the back rows, but we have the PRD. We need to make some decisions about whether or not the PRD is good. We're going to ask some of the agents for help. But we get to make the decision. Once we're happy with the PRD, we then move on to the next stage, which is just generate the epic, decompose the PRD into n number of epics. And again, during that phase of fanning out the requirements into something that we can actually work with, we need to have checkpoints, quality gates, human in the loop at every stage that actually matters, that's going to make an impact on the output we get out of the whole thing. The epic gets broken down into stories. Again, we validate the quality of those stories. And finally, ideally, during the execution, we also have decisions we need to make. If the inner loop doesn't raise any alarms, if everything goes perfectly as planned, that's unrealistic. That's not how anything works, right?
Yeah, before moving to that, let's could you return to the previous one for a second? So, what story really mean for us? What epic really mean to us?
Well, that's a good point. So what's a PRD to you guys? We said it's not 200 pages, right?
We hope, at least.
Anyone?
Yeah, it's a.
So product requirements document, right? How big or small should that be? The requirements for the product? Go ahead, please. That's a very good assessment, although in our case, it's going to break completely. So we end up with, let's say, 200 pages. That's the entire product. What we've found to be working much better is we write a PRD per feature.
Yeah, so it's the first time when we start working with that, our PM come to us, provide us very big documents, and basically, okay, this is everything that we need to build for this product. And to us, okay, but how are we going to deliver that? When that should be done? Probably in 3 weeks to 3 months, everything should be delivered. And you're using AI, you should be built it fast. Okay, but how? What that really mean for us? It's an entire product. And to us, okay, but who's going to read that? You? Then the next point together with was how we're going to read that, how many weeks we're going to need in order to read that to understand the product, because we need to feel the product as our own product. Able to understand the product as well as the only way.
The whole point. And this is sort of the flow that I just described a bit ad hoc, but we have defined commands in the folder in the repo, and we have the PRD. It's a list of open questions for the human in the loop, i.e. everyone present here. Then we triage, basically. We figure out what do we need to answer now, what decisions do we need to make right away, can we defer something? Let's say you're actually building an MVP and you don't want to answer all of the production high availability questions before you've started building anything.
Yeah, removing something is good. So moving something out of the scope is the best thing that you can ever do in your life. Yeah, sorry. I'm always removing something from the scope and all PMs are hate me. Yes? Very good question. Looks, we have architectural decisions here.
Yes. So that's the second stage.
So the architect agent will have the rough idea, which then will be like inherited from the backend developer.
The idea is that that architect over there, the solution architect, is going to provide you a brief architecture of what should be done. It's not need to go into the details how to implement it. It's going to provide information like you need to build a webhook, probably which database is good enough for your case. It's going to provide you information how probably that should be deployed, or everything around that, how many services, only the overview of the system, but it's not going to go into details. It's not responsible to the architect to go into those kind of details. And yeah, so
think about working with a good architect, right? So maybe Stefan, if you were you good when we were? Anyway, so working with a good architect, what it means is he's the guy who's going to be translating the business vision, but not prescribing the implementation details. Like he's sort of a bridge between both worlds if he does his job very well. He gives you the rough shape, he sort of maps the topography of the whole thing. And he also puts the boundaries around the system, otherwise it's just something that's never going to be finished. So we want to achieve something similar here, so that he is at level 2. Once you actually have the business requirements, reflects one or more epics. Goes forward and backwards again. PRD. So ideally, if you do it well, you can trace every story back to the PRD requirements. You can also trace every technical record, every technical decision, architectural decision to this stage here of this workflow.
And something to add to that, because this is the most important piece to understand and basically use in our daily work. The way out there we go to the production Wednesday. Everything should be shipped.
Real QAs as well.
No,
We build the agents for the QAs, but yeah, that is the main point. So we try to stick the stories to something that is deliverable.
If you don't actually decompose them properly, you end up with the 15, 20,000 pull requests, like 15, 20,000 line pull requests.
It's very hard.
You want to decompose into small chunks of work like a real human will actually do it, because you get chunks in, you get small chunks out, easier to review both by agents and humans. And then, like Stefan said, ideally, you also optimize a system like this for continuous delivery. You get all of the benefits with trunk-based of something that goes through an automated process end-to-end. Like that's what we're targeting as well, which it's a bit more difficult to achieve in regulated finance than, let's say something like...
That was the reason why we can return back to crypto, something.
Yes, I think we stuck around in this slide for quite a while,
Yeah,
but
let's move forward.
This is probably the takeaway from our workshop, like the theoretical one. This is the gate I mentioned several times already. So whenever we reach a point where we need a human in the loop, we need to figure out what the boundary is, i.e. detect it. We need to discuss multiple possible options. So it shouldn't just be, should we go with Kafka or
something better.
Yeah.
Probably not. Probably Aaron.
So obviously you need options. You need the architectural trade-offs of each of them. So that's why a lot of the implementation level, like during the implementation phase, a lot of decisions might actually have to be revisited. You might have to bubble them up to the architect. And if that doesn't happen, you probably haven't made a perfect plan. It's just somewhere in the inner loop, in the implementation, something's missing. Because this is an imperfect system. Like the LLM underneath is, random token generator, basically. So we block whenever there is a human decision required. You have to basically halt and catch fire, right? The LLM can't assume anything. It can't go on without looping you in, or at least we don't allow it to. And obviously, when we make a decision, we record it for posterity. New generations of agents get more context. They can figure out when, why, what. And that's it. One major caveat, I think I very briefly glossed over it, but the agents themselves can't actually run the block. They advise in the sense that they just propose something, and the command itself, the way we framed it, is that's where the block is actually raised. That's where the room is going to be pinged. Guys, what do you think about this one? Should we actually use Kafka or not?
Yeah.
And then the agents,
The always answer to that question is no, if you don't need it.
the agents, unless they are at the implementation level, think QA engineer, backend engineer in the roster we have today, or DevOps, they don't really just throw random stuff around. They're the only ones who can edit, yes, but yeah, most of the agents we've defined as read-only. So again, I sort of highlighted that we have an outer loop, we have an inner loop. And Stefan and I have previously talked about this at a different call, but we tend to front load the thinking. Basically, the outer loop is where we block and we loop in the human on stuff that's blocking the planning stages, right? So if we go back to the feature level PRD, we do a lot of heavy thinking, iterating, brainstorming, and planning. What we end up with is something that's as close to the vision for the system that we can probably get without writing a single line of code. But there is always going to be something in those plans that's not crystal clear, that is going to be explicitly noted down as this is going to change during implementation. And that's normal, that's how it should be, because then when the agent, let's say the backend agent, hits a decision that doesn't make sense during implementation, it shouldn't just make a random guess and go on. It should loop back to the human, the architect, the agent responsible.
Stupid question to all of here. How many times when you read a story, there was already defined technologies and you're thinking that that particular solution is not gonna work? Does somebody be in that case? I personally been in that case many times when I was a developer. The architect provide me everything and think that everything is ideal. But when I start working on that, I found that this is bullshit. And what are you going to do in that situation? Do you going to escalate that to the architect or you just gonna do it? In our proposal, in our way of working with the agents, basically, they should always escalate. We shouldn't agree of decision of somebody who never touched a code, at least as an architect. I was in a situation when 2 years I didn't write a single line of code. I just know all of the technologies, but that's it. But the people who are writing those codes know better than me how that should work. So in our agent flow, we always try to escalate back in order to get that iteration, that loop mentioned. And the main escalation point is here in the room. So it's basically the human who is taking the final decisions. Sorry for interrupting you, Rubo. But I was in that situation many times during my work as a developer.
It's a good clarification, because otherwise what you end up with is code you haven't read, but also code that's subtly wrong, and you have to then dig up stuff at 3 a.m. in the morning when it breaks in prod, which no one wants. So let's get to the stuff we've actually chosen for our small, it's a pretty small demo today, right? Like one thing we've noticed, and probably like the whole industry has noticed at this point, is that letting the LLM just randomly read files and try to map some code graph doesn't really work that well. A couple of tools on screen. The one on the left is something I've actually spent a couple of months working on, and it's become a bit of a monster project. So it has repository DNA, automatic context. It basically uses deterministic tooling to build a graph of everything. Code index, similar idea. Both of these just work deterministically to build the context for the LLM to use. So you don't get a million tokens of grepping and reading.
Could you guess which of those tools we are using in our company? Right or left? Why? No, because it's built by Rubo. That was the reason why we're using that.
He said right. We're using the one on the left.
Depends. If I'm here, the right is the correct one.
Yeah.
No, joke aside.
Enough self-promotion, though. Yeah. But here's the big kicker for me personally, because we all know that all of the frontier models are just doing strip mining right now. If you're not using something to optimize the output tokens of all of the random commands, you're just going to burn through your budgets very quickly. So highly recommended. You want to take off?
Yeah, okay. So there was some other stuff that we're basically using in order to build our context, or at least to save our context. And I was recently in a situation when I'm working a couple of hours and my context basically go over 1 million of tokens and everything go down. I need to compress, I need to save that. And what happened if my MacBook crashed at that time? So Cloud Code saved some part of it, but it's not enough. And there was a tools which we can use to sort that out and basically help us. Those two are CloudMem and also memory powers. They're basically almost the same things, but in different way. So in the one, like memory powers, you basically say, save me that, I'm going to need that later. In the other side, with CloudMem, it's auto capture. So everything which is auto in the world of AI basically could catch up something that we're not going to need anymore. So it's basically proof of cons what we're going to use. I have an issue with that, but I'm not using those tools because I'm lazy. I don't have time to install them. I have my team which is doing the work for me. So I'm just the engineering manager, tell them do the work, and they're basically using those tools. Most of my team are using memory powers, so it's good. I'm going to suggest that to you, but you need to know that they exist. And basically, you're going to see which tool is better for you. And we have some kind of comparison between them. So we have functional continuities, like memory out, everything is done automatically. And we have something that we decide when. And because we're going to talk about human in the loop, probably we're going to use the one who is basically the human in those interactions, so memory powers. But there was a cases in which we need to ensure that everything is captured and always used in our project. And this is the place where we use CloudMD.
By the way, just wanted to highlight, most of the papers nowadays, they're going to tell you that you need just the right amount of context. So memory palace is better to achieve that.
Yeah, but if you need to enforce the Cloud Code to do the work that you want to be, for example, in my case, I should write low latency Java code. And basically in the CloudMD file, I specify that you always need to use the skill code. What was the name of the skill? Low latency Java skill. Let's name it in that way. So I always provide that because my code should be written in the way how there is no new anymore. There should be buffers. There are a lot of stuff that should happen in the system. So I provide that information as CloudMD as a requirements to how the agent should write my code. What we're going to need for this, so we're speaking for about 40 minutes, but we need to start basically doing the workshop. So we're going to need a couple of stuff. First of all, Java. We're in the Java conference, so you're going to need Java. The next thing that you're going to need is Maven or Gradle, depends. You're going to need Cloud Code, so please install that right now if you don't have it. Also, for those who have a subscription, it's good. For those who haven't, there was 2 API keys in the repo that we shared in the beginning. Please use them. They have some preferred money, so we can use them and throw them away. This is the link. There is no QR code, but let me try to find the QR code one more time. If somebody missed that, let's go back. Okay. Let's take 1 minute for everybody who is interested to scan the code and follow us during that workshop. And could somebody confirm that this is public repository, because last time I'm not exactly sure. Okay, it's public. And you're able to clone it. Okay, amazing. So the code didn't do a mistake when I asked that. Amazing. Okay, so let's see what was our last slide in order to move forward. Okay.
It's probably
How many of you have Java already installed? Or you should install it right now? Okay. We're in the Java conference, that it's normal. Maven or Gradle?
Never
Why?
known.
Why? Very good answer, but in most of the projects, somebody already took that decision for you. And just a funny story. We used Maven in one of the company that I work for, and we hired new architect. And that architect came to us and say, okay, let's move together. And I asked, okay, why? No answer. Again, why to do it? No answer. But in reality, you need to sell your idea. If you don't able to sell your idea, you're not doing anything. And this is the same. The same architect come to me. It's a very good architect and tell me, okay, let's start writing our services to Kotlin. And I asked, why? Because Kotlin is better than Java. And this is where the conversation basically ended when I heard that. But in reality, if there is enough points, why not? I'm personally writing right now Go and also some kind of TypeScript.
Be honest, man. You're writing English.
Yeah, I'm writing English. That is a good point. So after the workshop, there was a bunch of information that you can get from the repository, and we're going to go over everything that you're going to see right now. And at the end, you need to remember a couple of stuff. If you're not agree with what the agent said, stop it. This is the same situation when you're in, sorry, Thomas, but I'm going to speak about with the man for a second. It is the same situation when you're with your wife and your wife starts speaking a lot. Stop it, put something in you, do something like that, or drink more beers, it's going to end in the same situation.
Yeah. She's going to be mad at you either way.
Let's begin. I'm so happy that my wife is not going to watch that. So that was the reason why I'm doing those jokes. Okay, let's begin with something. So I hope that all of you already have cloud code. And yeah, let me show where the keys are. That was something important. It's in document called key.txt.
No way.
Yeah, and there was a big issue when I tried to push that. I tried to do it at least 10 times, and GitHub said, there was a key inside. Are you sure? Yes, I want it. Okay, so let's try to zoom a little bit. First, let's start with the pair key. And does somebody know how to just use view not text to be more good? Is that no?
Can try Control V, Command V.
And close R. How to do that? How to go into present mode? Okay, let's try to go in the stupid way. Okay, let's first read that. We need reliable WebSocket processing for payments events. How many of you are in the payments domain right now? Okay. Racho, raise your hand. You're working for the payment company. Not anymore. Not anymore. Okay. So what was the issue? We get a lot of complaints, a lot of customer support tickets that something is broken, unpaid, the system is reliable, and it's pain of us. And what else? There was an issue with the money. The people want her money become something very strange.
The bigger one, double charged.
Double charged. That is good for the company, actually. So, yeah, imagine you are building the system and charge your clients twice and they don't do any complaints. That is good for you, isn't it? So, as I said, you need to think about product.
Maybe we should actually create a compliance agent as well.
Yeah, okay. What else? There was a couple of events that we should get. Payment succeed, subscription canceled, refund created. Everything is delivered over the HTTPS, which is good. It shows that our PM know that HTTPS is better than HTTP. We hope at least. What else? There were some losses, okay. The event could be delivered or no. Oh, it's not about SLAs. Okay, it's good. So we hired good PM. And what else? There was a good description about the problem statement. There was goals, which is good. I'm not going to read them. There is no goals.
Out of scope is as important as what's in scope.
Why we need to have out of scope? Could we do everything in once?
Should you?
I'm asking you.
I don't think so.
Why?
Yeah,
We
we
tried
tried
that.
and failed miserably.
How
Yeah.
many times you felt when you tried to do everything in one shot?
So,
Tell
done
us
it a
the
number of
story.
times in personal projects. Those have zero risk, right? But when you try to one-shot a back office system like I did, it took me 2 months to actually set it up properly afterwards.
Okay. What else? There was functional requirements. That is good. We accept post. You know what post is. Fine. We need to confirm. We need to acknowledge. Okay. Each event eventually updated the writings. Very good English. Writings. What writings really mean for us? Depends. Okay. So we need to understand that later on probably. And then that fail processing are retard automatic. Retried? Okay, not retard. Retried. Okay, amazing. Could you retry the same event multiple times? What we need to do? It's something that we're going to decide here as a rule. Support, okay. User stories, it's real good. Open questions, and timeline. When we need it? Soon.
Yesterday.
3
Oh,
weeks.
sorry, 3 weeks.
Okay. Let's go over our README and see how we're going to start. Let me open the README. And probably there should be some instructions how we're going to run that workshop. A little bit down, probably. Okay. So first we need to start with PRD review. Is that? Yes. Okay, we have good diagram here. Qualcode is very good for writing those diagrams for us. And we need to start with PRD review. Okay, let's go to the terminal and try to make the terminal a little bit bigger. Okay.
More bigger.
Let's jump inside the agent, a little bit more bigger, probably. Okay, let's me first check that I'm in the correct directory because...
Do you see well in the back rows?
Yeah, is everything fine? Are you able to see at the end? Or I need to zoom a little bit? Zoom. Now? Should be better. Okay. Let's start with the first. PRD review. Let's see what that is going to do for us. The first question, are you going to find the PRD document or not? PRD, provide the PRD path. Okay, there is a PRD in the rep level. Okay, the quadcode looks like not so stupid. It told me that I need to provide a PRD. Okay, I'm providing the PRD, and let's see what that is going to do. First of all, it's going to check some comments. It's going to check if the quad exists. Okay, the PRD is read. The quad gets absent, okay? And it's starting to do something. First of all, look, it spam the product owner.
Of course it does.
Okay, we need to answer why, but let's look what that's going to do.
Oh, we
The product owner-
promised that was what was going to happen.
What?
We promised this is what was going to happen, right?
We can see in a minute. But what does it really do for us right now? Let's open the command to see until we are waiting, because, you know, the agents are always slow, unfortunately.
So it's really MD files all the way down.
And sending a bunch of information over the network. Okay, PRD, and the first one is the review. Okay, let's go over that. Look, what is here? What is that, Rubo? Could you
Those
remind me
will
what
be
that?
the allowed tools that can be used by this command.
Okay, and what was the last one?
Oh, this is the one where we actually get involved.
Ask user question. Okay, and what
So
was
see,
the idea?
The command owns it, not the agent.
Okay, so the command knows those tools and know how to use those tools. Amazing. Look, we have usage. And the usage is basically provide us guidance how to use that command. And I felt, if we return back, look, I failed to do it. I just do PRD review. And what the command suggests me, do it in that way. It's gonna work, probably. Okay, and look, there was a requirements. We have a couple of requirements that command. We have some kind of rules, human in the loop checkpoints. We have ask user questions block. Interesting. we have some datetime, and also some kind of pref-writes, instructions. This is where things start to be interested. And what we're doing in that section, Rubo?
A couple of interesting things. You actually have to delegate to sub-agents. Usually that's what you do with commands, skills, whatever. They still have to maintain the reference frame. The tool calls are still limited. You don't give it more power. But here's where it gets interesting. We delegate to the product owner agent specifically.
Okay, and what was the output of that?
Well, work folder, PRD, analysis of the PRD. And then when it finds issues with that PRD, it's going to raise it to us.
Let's see if that's working. Right now, we have a questions. Okay, which of those blocks epics decomposition? Unselect for deferrable and see. Okay, Q1 retention period. How long to keep raw events payrolls? Compliance owned.
Any compliance people in the room? We might need help.
Okay. Let's say Q1 retention period. So no more than 1 Q. Okay, the second question is, could we get orders out of order? Could we get events out of order? What do you think, guys? Is that possible? How many services you are going to have? Only one? More than one? What is the best pattern when you're deploying system? How many services you need to get in order to go with high available systems? Somebody? 1, 2, 3? How many services?
As many as you need.
How many we need in order to be high available?
Let's say we want a minimum of 3. That's a guarantee that you get out of order events.
Okay, if you have 3 services, could we go out of order then?
I mean, I sort of spoiled it for the room, but yeah, it is going to happen.
Okay, so let's mark that. Data store choice. In which database we're going to store that information? Probably we need to answer that question somehow. Could be Mongo, could be Postgres. There is going to be a good conference in a couple of months here in Sofia about the databases, but we need to answer that question probably. Okay, what else? In memory. Actually, in every trading system, we store everything in memory. It's fast. But at the end, it's very interesting.
Well, eventually it goes to disk.
Eventually, it's the good point. Okay, so we need to have a mapping between the customer and the user. What is customer for us? What is user for us? And what is the customer and the user for the payment system that we're using? I'm currently doing Stripe integrations a lot, and it's very complicated. What is the user for me? It's not the user for them. So we need to do that. Okay, let's move. Semantics. Do we need to have exactly ones, or we need to go with at least ones plus idempotency? What do we need? Okay, I'm going to check that in order to see.
It's a good decision to discuss.
It's a good decision to make.
Yeah.
Acknowledge versus durability budget. Okay, this also go good. We're not going to go over the burst, so let's skip that for now. Fully processed.
Those are rookie numbers anyway.
That's good. Ops. Okay, what ops is? How many of you are doing supports right now in your product system? Anybody? Support?
On-call rotations?
On-call? Paper duty? Yes? Nobody? You're so lucky.
Hey, pager duty is nice. Just
Okay.
not at 3 a.m.
Let's say that we're not going to take care about that right now. The room is so swine, so we're not going to do any kind of rotations. Let's keep them. Okay. Owner method timing. Probably we're going to need that. And let's submit. Let's see what's going to happen. We're going to wait, but on that time, we can scroll a little bit back and basically go over our comments and our agents to look them in details what they really are. So we're going to go over the backend developer until we're waiting and basically see what was there. We have very big descriptions. Use this agent when you need hands-on backend implementation. Okay, amazing. And it looks that this is Java-specific agent. It knows Java, it's no Spring. Oh, it looks that probably no Kotlin and TypeScript as well. It's good. There was example, which is fine. And we select which model to use. And we basically choose the best model right now, or at least the model that it's more expensive. So we want to basically send our money to.
So this is the one that can do a lot of stuff, right? Because obviously this is one of the agents that needs to touch files.
Yeah, look, also, we're describing that this agent is senior backend developer. We're hoping to have more senior backend developers in order to write the agents files like that. So, okay. And expert purposes, we also have some kind of information how that should work. And compliance checklist. Document architecture rules acknowledge. Build system identifier. So we have some kind of checklist that agent should go every time when we are running that and basically put check marks. Documented architecture rules. Check, check. Test command identified. We need to run our tests, unfortunately. Yeah, we know nobody of us will write tests, but we need to run them. And look, we also need to format our code. So those are our checklists that we need to run every time. And yeah, we need to go with modern Java 21. Are there somebody in the room which uses Java 8? 8. Tell me which company you are. I'm not going to join that company in the future. Java 5. Java 5. Is that still exist?
Probably in quite a few places in banking.
Where?
Banking.
In the banking?
Yeah.
But, okay. I'm not going to join your company. You need to double my current salary in order to join that company. At least. Okay. Spring Boot, look, we're using a little bit old version. Spring that, it's fine. But let's see what happened when we review our PRD. And look, we have 8 blocking and 5 deferrable items. Artifacts are written in those directories. Okay, let's go and check what those artifacts really are. Can I close all of those somehow? Yes, I can. Okay, it should be in which directory?
Work.
It should go to work, PRD, PRD analysis. Okay, and this is the entire analysis from our agent and our comments. It's reviewed, we have a date, it's a source from where that it's done, and there was a bunch of information inside. So it's good to read that, probably. There was open questions and all of that written down in that document. And there's also decisions, okay? Look, there was decisions as well. Okay, what we need to do after that? The PRD is already analyzed by product owner. All of the decisions are there. The PR analysis document is there. What we need to do? Let's go back to our flow. What is the next command? We need to run this one probably. PRD to Epic.
Let's try that one.
Let's try that one and see if that's gonna work.
So
And just to mention, this is the first time when we're doing that.
well, live.
Live.
But
And we never test those commands. Group update them around the midnight, and at that time I was forgetting to pull. So everything could go wrong. And that was the reason of the workshop, to try it right now with you.
yeah, you're basically our beta testers, right?
Yeah, you are our better tester for this project.
So jokes aside, when you're writing production systems with a workflow like this, you often actually get a lot of iterations. So after each command, you do a pass to verify the quality adversarially. So basically not in the same session. That's the whole point. We actually have commands that verify the outputs of commands as well. Just teasing out some of the...
Verifying LM with LM. Okay, what
and
we're
then
doing
eventually
here,
the
Lubo,
human goes in there.
what we're doing here?
So what's going to happen now is, let's say we've approved the PRD finally after several iterations with agents, several iterations with the real PM. Now the solution architect agent is going to do an in-depth analysis of the PRD, of the decisions that were made. It's going to take a while because that's sort of the big chunk of work that needs to happen to actually get the proper output we want.
Is that going to ask a question?
Well, probably will, because we didn't actually do the work with the previous stage, right? So we're going to get halt, catch fire, stop and ask, basically, here as well.
And please, never go in out mode. Never. Believe me. A lot of mistakes have happened with that. Why I'm doing that? Because it's easy for me and I'm a lazy guy. But never do it in production systems. This is my personal laptop. That was the reason why it's on. Not in...
Yeah, let's say an LLM isn't exactly a good judge of where a tool use is valid.
Okay, until that it's running, let's go basically and explain to the people here that we also have some templates. And what was the idea of those templates, Robo?
Templates. The moment you actually have to get some structured data in place and you don't want a database in the whole picture, we use a lot of MD files structured to get the same consistent output for each ADR and then for each story as well. In our real-life work, we have quite a few more templates than these two, but for the workshop today, we just defined the two you see on screen right now.
Okay, so we have EDR template and story template. Okay, let's see where we are with the architect. It's still running. Looks, it's burning a lot of tokens.
That's just the main agent, by the way. It's burning a lot more, probably.
Yeah, so we're still waiting. Until we're waiting to see the outputs here, let's look what is also there in our repository. So we have rules, but we never open them. Rubu, could you help me to understand those files? Why we need those rules? How they're going to help us?
Okay, so Claude as a harness actually conforms to these rules a bit more than an LLM actually just randomly would. If you noticed when we were running the PRD review command, the file was at the top of the command itself. All of the commands actually reference this. This is the main protocol we have for how the agents are supposed to interact. So I did say that it's a small lever because there is a lot of things are actually happening in the deeper layers, but it still actually helps us control and frame a lot of how the system is going to operate. So the agents stop when they have an issue. Like, if nothing else, this is what we want, right? We want the architect to stop and actually offer us different options so we can discuss them and figure out which is best for us.
Let's ask the room what we need to select here. And they probably one question from the room, what we are doing until we are waiting, because you see that we are waiting around 2 minutes, 5 minutes. What we are doing in that time? We have another session and we are working on more than one story at a time. But another round could be drinking coffee, speaking with colleagues. So it really depends on what kind of company you are. We personally have at least 5 or 10 sessions like that, and we are trying to work at least on more than one item at a time.
Yeah, so the whole close to burnout situation is actually worse now that we have AI in the end, because you start a task, let it roll, start another one, let it roll, and then eventually it's just complete exhaustion from all of the context switching. So we've actually tried to limit ourselves a bit.
Yeah, okay, so let's try to take that decision. Should we use Postgres? Raise your hand if you think that the Postgres is good for this use case.
Okay.
The use case is just, okay, we need to build a webhook system which accepts payments from systems like Stripe or some other systems.
Here's the question though. Ingestion, idempotency tracking, dead letter queue for the events.
Is the Postgres a good or not choice? Could we go with just embedded H2 for production? In which company? Okay. Could we
Stefan
go with SQLite? Not really. Okay, so the Postgres is a recommended one. Let's click. Okay, delivery guarantees. What we are going to get here, Gobo? Tell me, which is the better? At least once.
Are you sure about what exactly you want in terms of consistency?
Very good questions.
Should you
I want to
maybe
ensure that there is no
ask them?
double processing of any events ever.
Guys, what do you think? Exactly once or idempotent?
Which one is better? Sorry? Raise your hand if you think A is good one. Everybody in the room. Raise your hand. Okay. How many think the second one is better? Are there any pros and cons? Rubo, what do you think?
Think distributed systems, guys, then the only answer you have is one.
I have one. Okay, why not exactly one? I read in a lot of books that HTTP with database could be exactly one. So there's a lot of articles about that. I'm joking. So let's move with A. Okay. Must durable writes complete before the 5-second acknowledge? Yes, this is the requirements.
One interesting thing you'll notice, it actually has recommended, obviously you've seen it when interacting with Claude Code. Most of these are fine. It's the ones that aren't where the human in the loop value actually emerges.
And this is the reason why we're here, to look what the Claude Code recommend to us and basically choose the best. And we can just type if we want to do something else. So you have opportunity to provide your guidance. Okay, let's go with A. What else? How we are going to do the dupe? Whoa. How are we going to do that? Okay, let's try to think about it. Are we going to have different systems, or we are going to have only PayHub? No. PayHub. How many systems we're going to support? Is that a good question to ask?
Probably a business person, right? Do we want to ever support anything other than PayHub?
What do you think, guys? Is it safe to run with only one provider? Why? Single point of failure. Okay, probably we're integrating many different providers in one of the companies that we work together with you. But yeah, it's a big problem. Then, let's ask other questions. If we go with two providers, are there any possible way they to have the same event ID? Is it possible? Okay, so the first one looks, it's not gonna work. What about the second one? Do we have the same problems there? Could both have the same content hash?
Unlikely.
Okay, so let's try to type something else. Let's try to do, let's use event ID plus name of the provider.
Plus content hash.
Okay, plus content hash. This will enable us for future, for adding new providers. Okay. Are we happy with all answers and all questions? Yes, let's go. Click submit. And now we are going to wait again. So we can go take beer, because I'm seeing very good beer in Plovdiv here. It's called Hills. But yeah, we can go grab beers, discuss something, or work with something else until that is done. But because we're in the workshop, we can go and basically look some other files that we have in our repository, because this is also important. So we never go over which was the file. Yeah, okay. So we never go over all our commands. We have epics, we have PMs, we have PRDs, we have stories. But let's go and look them and basically try to go and see what they are doing. So, Rubo, why they are structuring it that way? Why they are structuring those folders? Could we put everything in one folder and make our life a little bit more easy or not?
Of course we could. It's just you probably get some collisions with the global commands / skills.
What global? You mentioned skills. What skills are? I have skill to play football probably, or I wish to have that skill.
You do? We gotta try that sometime.
We can
Yeah,
try.
so
If we come to
Claude,
Plovdiv.
Claude ships with a lot of global stuff. It's a very mature harness at this point in time. When you define custom commands like this, it's good to actually have a namespace, literally a folder, that you can then /epic and then column, then command, preface them with.
But what is the difference between the command agents and skills?
Oh, those are muddy waters. So they're all text, right?
Everything is text. Our code is text, probably.
So it's a bit of trying to frame the what and the who, right? Like we have the agents being the actors on the stage. We have the commands, which is what they're supposed to do. The skills are basically the same thing, but with a bit more added on top. And that's what everyone is actually writing nowadays. So we are probably behind the times when we actually show you guys commands rather than skills.
Okay, so we have commands and skills. Amazing. When the skills are used, do I need to specify the skills to be used or how? Are
Well-
they running automatically?
Yes and no. You could actually execute them automatically if you create a plugin or an MCP server is actually connected. But in our case, we want to run them manually.
Whoa, we have another set of questions.
Interesting.
Yeah. Who could you help me?
Well, I think we already answered the one about the out of order events.
What we can retry, trade missing. Okay, what should I answer for the first one? Should we try to reorder them? That could be problematic. Guys, what do you think? What was the correct one? Somebody raise hand that you work in the payment systems. Those could help out because they're payment experts. We are not. But what we should do here?
Do you need global ordering?
What that mean?
That means a completely accurate ordering of events.
I don't think so. I need events to be ordered by customer.
Well, then, I guess the middle ground is fine.
Which one? The first
Retry,
one.
yeah.
Okay. What else? ID mapping. How the mapping is gonna work? Well, mapping table sounds good at least.
Don't need to make it more complicated.
Okay, what about the whole part dependencies?
Oh,
Should we use
interesting.
Hikari or we can go manually with JDBC driver only? What do you think, guys? Do we need to Hikari or do we need the pool? What the pool really gonna help us? This is a question. How many of you using Spring? Raise your hand. Okay. How many of you are configuring Hikari pools ever? Touching the configurations. Why? Tell me.
You can touch the number of connections and all of that.
But why you did that? Do you have any reasons?
One colleague just used the defaults or didn't configure it at all, so we should put some reasonable defaults. Like it wasn't what to click, but
Okay. Could we go without Hikari pool? Is that a good idea?
I mean, do you want to maintain the pool manually?
Me personally, no, but probably people won't. Okay, so let's keep the Hikari pool then. Okay. How does the one part when a new event exists? That's a tricky question. Looks, there was a Kafka again. Okay, so Are there any issue with scheduled annotation? Let's think about that. In the beginning, we discussed about number of instances. How does schedule annotation is gonna work if you have more than one instance? Are all instances are going to process the same things again? Or what? Have a leader elected. Do you know is that possible with the scheduled annotation? Just.
It is.
It's supported? In which version?
3.3, I think.
If you present me that to me after this workshop, I'm going to personally go and grab one of those beers and send it to you. I'm not going to pay it. I'm a student, but I can take one beer and give it to you. Okay, so DB notifications. This is something that I hope that I'm so happy that I've never seen my wife. Dedicated queue. It's overcomplicated. So
Depends how many users do you have.
how many users? Very good question. We don't know. We should ask that, but let's try to go with scheduled, and we're going to run only one instance. We're going to handle the rest when we need. Never do a mistake to overcomplicate the system in the beginning. Never do that. And there was a real story in my life. I was working in one very, I would say, big company with very good product, but they decided to break the monolith in many microservices. Without clear reason, without clear strategy, and they was thinking that tomorrow they're going to have 10 million customers. Now they have 5. So
5 million?
5? Less than that, but in the reality, you should try to not complicate your system in the beginning. Keep it simple, always. So let's go with the first one. Okay, let's submit that, and we need to wait. Oh, that was fast. Okay, we're waiting for batch 3. There is product metrics. Do we need product metrics? Oh, there was a bunch of other questions. Rubo, help me.
Yeah, you see, we agree that we're going to keep them for a queue, right?
Build a configuration retention mechanical part. Okay, what was that? Could somebody help me?
How long do we keep the events? We said 1 quarter, but how do we ensure they're deleted after a quarter?
Do we need to delete them? Could we keep everything forever?
How much money do you have?
Let's see. Where's my wallet? Only €1. Is that gonna work?
Ask Bezos. He's probably not going to like that.
Okay. So what we need to say here? Fixed short window, let's say.
Let me reframe this. Do we know the answer from compliance?
No.
Do we need to build this today?
Sorry?
Do we need to build this right away?
We need.
Can we add it on top? Can we add the cron job that deletes stuff?
Why not?
Then maybe. Let's start with 3 and then we revisit.
Start with 3. Okay. Amazing. What was that? What counts as fully processed? What does it really mean for us? Let's go with the first one, I would say.
Yeah.
Sounds like correct.
DOQ shouldn't be in the process.
Okay,
once.
data cleanup. Autobahn one-month NEP finance PM org. So we as developers, we shouldn't take product decisions. Always ask those guys. We have agents for that, but we're developers. So all of the business decisions should be taken by business people. So
not to be confused with the We Are Developers Conference, right?
yeah.
We're the jPrime one.
Okay, let's go with the first.
Oh, yeah?
Okay, now we're done. Not really. Now we provide enough answers to all of those questions. And this is our work right now, to answer all of those questions that agents and comments ask us.
So the architect is probably now going to create something that we can then iterate over.
But it's the good first phase at least. Okay, we're writing ADRs. Look, so all of the architecture decision records that are required for this time are going to be produced right now. So it is going to answer the questions where the architect finished. It's finished here for now. But later we can escalate to the architect if we need it. Okay, now there was a bunch of documents. Let's look one of them, or at least a couple of them until that it's finished. It's slow, I know, but yeah. Where they are located, it's here.
Yeah, but that's the whole point, right? If
It's slow?
we rush through this stage of the project, the product development, we just get garbage out. Garbage in, garbage out. So
Okay.
optimize the quality here.
Okay, let's look that. What was there? The loop is decomposing. It's created by this particular command. The artifact which we used, it's epicmd. Okay, and this is the everything that we took as a decision. So we basically choose to use Postgres. Why? We want durable store. Okay, options considered. So we look only 3 databases and we choose Postgres, which is good. If we need to build that in the real world, probably we're going to add a data expert as well. Because we want somebody who knows better the databases than solution architect. Believe me, we need to check many different databases. So
Yeah.
I personally use at least 5 different databases. And without a database agent, I shouldn't use the correct one.
You
So now
actually
we
have
decided
more,
Postgres.
more than one.
Could the Postgres is good or not? Probably for now. Is there a better database than Postgres? Somebody? Better database? Yeah, go ahead.
I want to say
MongoDB. Okay.
only reason that MongoDB is on SQL.
It's not SQL.
I hate SQL.
You hate SQL. What about the new SQL then? Do you know that there was databases which are new SQL database that promise to solve all of those problems that we have with SQL databases? You can check that.
I mean,
Probably then you're going to love SQL.
it's probably going to outlive us anyway.
Yeah,
So-
but you need to pay. Actually, there's no good open source solutions for that. But let's see. Okay, decisions, implications, revisit. Okay, for now, we're happy to go with Postgres. And this is still writing. It's basically updating stuff. Look, we're putting checkpoints. Marked. It's done. It's done. It's done. Okay. And now what we're doing here?
We're decomposing the
We're
epic.
decomposing and basically
No,
we're
wait.
creating
We're
epics.
creating the epic, right?
Yes. We're creating epics, but we provide the hits.
Happens more often than I'd like to admit. What was
And
I
there
doing
was
in this
pro-
session?
Look, there was a progress 0. What that mean?
Yeah, we haven't done any work yet. is
We
what it
never
means.
done any work yet.
Or at least that's the way it looks to the bosses, right?
But we work a lot. It was almost an hour of speaking and we never start yet. Why?
Important decisions have to be
Important
made.
decisions to be made. Okay. Let's see. The next command should be epic decomposite PRD. Let's verify that with the flow. Yeah, usually I'm verifying everything at least 2 or 3 times. Yes, this is the second one. Okay, amazing. Let's try to run that.
Didn't we call it webhook? Is it PRD?
I don't know. Let's see. It's coming to run that. And we hope that this is smarter than me.
Not
And tell me,
necessarily.
I need to buy more credits. Okay, now we're getting to the product owner. What else is going to happen here?
So basically, we have an epic MD, right? That's the architectural outline of the system. That's what the architect created based on the PRD. Now we have that. We give both of those artifacts to the product owner, who's going to do the menial work of splitting them into stories.
So what should be the output? The stories. The real stories that we can kick off and start working on.
Probably, if we did this right.
Okay. Let's pause here for a second. And if all of you are in the opening session, there was some kind of game, you can try to use this workflow and basically build the app that they ask and win the prize. So if you follow those steps and found a good idea for the app, and you basically create a PRD with the crowd and the agent that we can create or the commands that exist, you can try to follow those steps and basically build the app that was mentioned in the opening session and try to win the money that they propose to give us a cash.
Stefan is probably going to be winning that anyway.
I'm not going to be on that time tomorrow, unfortunately,
Oh, okay.
because I need to be in Plovdiv, but I'm definitely going to submit my app. So this is what I'm going to do tonight, drinking beers and doing that app for the conference. Okay, we're waiting. We're still waiting. Let's see what that's going to produce. It's reading files. Look, how many times we read that document? This is the fourth engine which reads the entire PRD. Is that use of tokens?
No, that's by design.
It was by design to pay money to Anthropic.
Hate it or not, that's the only way to ensure you, as the product owner, have sufficient context to actually do your job. Sorry, it as the product owner, right?
Okay, so yeah, the main problem here is that we're always gonna pay money if you want to go with flows like that. So there was very good plans that you can use. There was local models that you can use in your machines. But at the end, we always need to burn tokens. We're in the life when we're burning tokens every day, and
So,
a lot of tokens.
again, you can do it a bit more complicated. Like all of these can actually live in a local DB somewhere rather than MD files. Then you get two calls, you get something that doesn't burn as many tokens. You can use something that we already mentioned, either CXPack, Code Index, Graphify, multiple tools like this exist. You burn less tokens, but it adds complexity. So this is a very simple system that we're just using to illustrate the points. Ideally, people add a lot of stuff on top of it that actually serves their purpose, right?
Yeah, people are doing a lot of stuff with cloud code those days. Okay, we have something. We have 14 stories, and okay, a lot of questions. And it looks that we can start working on them probably. Or not yet. Oh, looks, what happened here? There was something, and our whoop is working. Look, it looks that we're starting again the solution architect.
So it's going to read the decisions that create conflict with the ADRs. It's going to obviously reread the ADRs themselves. And then we're probably going to get another barrage of questions where we have to make decisions, and they're going to be reflected in new ADRs, reflected in the stories, and then we can actually start working on the stories.
Okay, so let's rephrase that. Are you in the situation in your company when you're battling with PMs, other devs, or architects? In some meetings, there was a battle. Is that happening in your companies? Okay, and how do you deal with a situation like that? What are you doing? Just accepting, or try to battle with them? Really depends. The question depends of the company and depends of the effort that you need to put there. But with the agents, it's simple. The agents handle everything for you. So let's enjoy battles between them. I hope the solution architect is going to win, because all the solution architects are big guys. So yeah, let's look what we have at that time and basically see what else we can present until that it's done. So let's try to open the entire flow.
So while Stefan is looking for that, if you do actually use a memory tool of some kind, these conversations are recorded sometimes, the shouting between the agents, and they're really funny to browse through.
If you have time to read them.
No one does anyway.
Okay, so until now, let's go over the flows, because now we are going to start implementing the stories, which where we are going to end this workshop. But let's look at the flow one more time. So we start with the PRD. After that, we basically review the PRD. we asked questions. So that could be done by PMs, actually. So in the reality, PMs can do that. They can battle with themselves in order to answer those questions. You can build a grooming session with PMs and basically let's evaluate the PRD with them. So it's not only you or your team, could be the entire product team.
Exactly. Ideally, these things, especially the outer loop we mentioned, these commands and skills and agents, they go to other departments. This shouldn't stay in engineering. Otherwise, what you get is an inner loop, an execution loop that's optimized. Everything around it is dead slow. So we are actually trying to fix the outer loop as well.
Yeah, so the issue is that not only the engineering team should use the tools, everybody in the company should use those tools. So we want to build AI first company. Or at least we dream to do that. But that means that PMs, QAs, DevOps, everybody should use those tools. Everybody should be familiar with those tools and know where the responsibility ends. And now we're in a situation where our PMs are providing very good prototypes.
Oh, yeah.
And that is really fun because you can open and see in reality what they want from us. And yeah, it was really nice.
Basically optimizing for lazy engineers, right?
Yeah. Oh, we have a bunch of other questions. Oh.
Again? Really?
Again.
Oh, wait, that's the point of the workshop.
Yeah. Could you read them and help me?
So, let's see.
Read them, please.
Oh, out loud? Come on, man.
Yeah, we have a big group
Okay,
here.
so yeah, probably people at the back don't see them. So what bytes does the content hash component of the deduplication key cover? So this is a column with a unique constraint computed on the Java hot path before we actually send the acknowledge, the ACK, back to pay hub. Interesting. So anything on the hot path
JSON on the hot path.
should probably not be JSON.
Not be JSON. What could be?
Well, multiple different protocols could be used here, right? You want something that's a bit more lightweight.
But
Let's
consider
not-
that in the Postgres you can query the JSON.
True. Do you want a JSON B column for this for now? Unless you want to pre-optimize it now.
It's a good question. Okay, what else we can do here?
We could try a different protocol. Not a lot of people who are financial geeks, so maybe protobuf.
Okay, so let's answer that. Let's try to go.
Here's where we actually discuss stuff.
Let's go with canonicized protobuf. Could you
Why
go
not?
with Avro?
We could. We could also do ASB, but you know.
Okay, the next one. What do we need to do in conflicts? What the conflicts really mean for us then? When two events share provider event ID but differ in the content hash, what happens? Is that possible?
So let's say PayHub, same event ID, but different content hash.
Is that possible?
In theory,
What do we need to do if we're not sure what happened with the providers? Should we ask them? What do you think? Do we need to read their documentation?
it's probably written in the docs of PayHub somewhere.
Probably. Could we use agents and comments to scrape their docs?
It's something we should have done before we started this whole thing. But yes,
Okay, then do you have a story to tell us what happened when we add one of those tools and basically what Anthropic did to us?
yeah. So Cloco has this Firecrow plugin. One of our colleagues actually got banned for using it. So yeah, there's that.
Yeah, so there was a very funny situation. We used the tool to scrape the data and basically have all the documentation locally. because we want to fill our models with that data in order to build proper documentation and in order to use the documentation in our decisions. But Anthropic broke us. Anthropic just broke the entire profile, and we are not able to use that profile anymore. So, yeah, try to think if that's okay or not when you add comments, tools, and everything to the crowd code. Anthropic could block you because they're thinking that you can scrape their information and use their models to train your own models. So we need to be very careful with everything. Okay, let's try to take some decisions here.
So
First right wins.
here is the implicit behavior right now. Both of these are going to be processed. The easiest way to figure out if they should is to read the docs.
Yes, let's go with first right wins. Okay, what else?
So, how much of the state machine does story 001 fix? So before I can answer that, I probably need to read the story, right? Let's assume I've done that.
Do you want me to open that for you?
Do we have the time? No. Let's go with full state machine now, as described in the story.
This one?
Yes, please.
Okay. Let's submit those answers and see what happens.
What's the worst that could happen?
Probably next bunch of questions. Yeah, we don't know what's going to provide to us. So the LM are not deterministic. We'll try to build them in some deterministic way, but we really don't know all those questions. We try to answer them right now here. So let's see what's going to happen. We're still going to wait. Bunch of tokens, 6 minutes. That probably is not correct. Okay, the room choice. Amazing. What else? Recording again new architecture decision records. Oh, we're expanding.
We're superseding
ADRs.
one of the ADRs already.
Why we're doing that?
Well, any good architecture decision record, by definition, should actually supersede the original ADR when a new one replaces the decision.
So the main idea is that the EDR cannot be updated. New EDR should be created to replace some other EDRs.
Think of it as append-only log, right? You want a complete deterministic history of all of the decisions made so that you can replay how the system got to where it got.
Okay, and now we should wait a little bit more, probably. Okay, let's look that the new one is replacing the 5th, and we should be ready to go, probably. Oh no, we're still waiting. Suspended by blah, 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 blah. Checkpoint, blah, blah, blah. Okay, sounds good. We're still waiting. You need the dupe, the key analysis. Amazing. Okay, time for coffee. But yeah, this time we'll just go drink coffees when we're in the office. Okay, all questions are recorded. Okay, what else there?
So now it's going to write the stories.
All of them. Oh, start writing stories. Let's look one of those stories. What was there? Xcode. Where is my Visual Studio Code? Okay. Epics, stories. Let's go with the... What was there, Rubo? Could you help me to understand that?
So what we just saw is it wanted to use JSON. We said something lighter, Avro in this case. So now it's going to probably have Avro in the story somewhere. Probably. Let's see. Can we find it?
No durable rights, no business processing, does not implement the concrete payload signature.
Yeah.
Avro.
There it is.
Okay. Amazing. Okay, this is one of the stories that we need to start working on, probably. There is no dependencies, so probably we can start working on it right now. And looks, we have a flag called parallel true, which basically means that this could be done with some other stories at the same time. Also, look here, we have depends on. What that is going to do? What was the idea of that?
So we like to build the dependency matrix between stories when we do this thing. This way you see, one, the critical path, two, what you can work on right away, like basically what's next, three, how many sessions you can actually work on in parallel.
Do you do that when you work with the teams, not with the agents? Do you have those dependencies written down in Jira somehow, link tickets? Are you doing something like that in your work?
Basically blocked by.
Blocked by your... No?
Yeah.
How many of you? Okay. I hate that part. It's too hard to me. Yeah, I was architect, so I supposed to be architect in different companies, but yeah. Okay, we're still writing, we're updating epics. All the tickets are done. So let's me try to do something else. Let's me open new terminal. And let's kick off.
Should
let's
zoom,
do-
zoom, 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 zoom.
Let's see what was at the end. Should be readme here. And
There are multiple commands now that actually you pick a story, start.
let's go with story start. In new terminal. Is that going to start all of the stories? Or what that's going to do?
Well, ideally, you actually provide a file /ID. It's going to figure out how many of them are written.
It's going to help you, look. It's basically say, I'm going to provide you a suggestion.
Like I said, this is optimized for lazy developers, right?
Like me.
We want to make our lives easier, not harder by using this tool.
Okay, let's wait. Do it fast, please. Be fast. No. Yes. And where we are. Okay, start to. Oh, we can expand to every read. And this probably is going to do everything automatically for us. Let's just go with the first two. Let's go with this one. And I probably could start another one, which...
Yeah, one piece of advice, I tend to stick to one unit of work in a session. I take one story, open a new code session, execute it, new session to review it, etc., etc. So
yeah, but now
running these two in parallel is going to probably produce worse outcomes, but we're doing this for the workshop.
Yeah, but there is no dependency between them, and they can be doing parallel based on the analysis. Yeah.
Why don't you use agents view?
Sorry?
Agents view, the Claude agents view.
What was that?
It's a new thing from last week.
It's new.
Yeah.
Could you explain that to me?
So basically how it works is it does the whole orchestration out of the box for you. You just open one terminal and then you can actually execute everything.
Yeah, I'm doing that at the moment. Unfortunately, but it looks that I need to read that.
So Agents View was actually built for you. I'm still pretty sandbox per session per
Yeah, I want
per
something
tab.
new. Interesting. I need to check that.
It's actually pretty cool. Think of the logical extension of the native Teams thing, but in... Yeah.
Okay. And let's stop here and basically ask if there's any questions. What do you think about that workflow? Is that going to work for you? Do you plan to try something like that or not? Okay. So let's wrap up here. We present what we're supposed to do.
I think we can open for questions,
Yeah, we're open
discussions.
for any questions, discussions, and everything. So if there is any question, please ask now or, yeah, go ahead.
So you guys mentioned that web scraping is kind of a no-no, and Anthropic is going to block that.
Depends how you use that. If you create agents and comments about that, they're probably gonna block. But if you just provide us a comment and say, okay, scrape that with this MPC, it's probably gonna work. So it really depends of the usage.
What we did, the specific case was we had a command that was actually using the Firecrow plugin under the hood, so it was completely autonomous. And I think that's where they draw the line. That's where it raises the flag for them. If there is no human in the loop who's actually doing the web scraping of the documentation, it's a red flag.
We asked them, but they didn't apply why.
Yeah.
But look, Rubo, there was two different agents that start working together in both. Why?
So native teams by default, they're going to launch parallel agents doing parallel work if a story can be executed in parallel.
Okay, but look, we have backend developers, product owners. Before that, we have solution architect. Why they're all working together?
Well, ideally, they shout at each other and make good decisions, right?
They're discussing between them. Okay, amazing.
Eventually,
I hope those discussions with my product owners and my architects a little bit more often, but yeah. Okay, any other questions?
So eventually, this is going to throw another decision our way at some point. It's going to hit, the inner loop itself is going to hit something that wasn't pre-decided. There it is.
They're asking questions between them, so sounds good. Okay, any other questions? Yes?
So these flows, is this basically what you use more or less in your work?
Yes.
Okay, and so we answered a lot of questions, right? In reality, how do you go about answering those questions when you have to talk to other team members or even other roles? What does the process look like to answer some of those questions when it takes more time? You can't just do it by your own, decide on your own.
Yeah, we have a lot of discussions with them. So in the first place, we are doing some of those things during our grooming sessions. So we take one story and basic one PRD and doing that with the PMs. And this is where we answer most of the PM-related questions. Later, we
Just to stop you a bit, do you like go on a session with them on a call and go do this basically?
something like that. We try to do as much as possible async, but we ask a lot of questions doing that. So we use plugins to store the sessions. So let's say there's a question that we are not able to answer. We stored everything, the entire context in the Markdown file. We ask that question on Jira or some other channel, if we're not doing that in the call. And when they answer that, we return and restore from where we ended. And that was the reason why we're not working on only one thing at a time. We're trying to work on many items at a time.
Yeah, because ideally, if you have to wait for compliance to answer a question, you work on something else in the meantime. Like that part of the work is still slow, and that's why we try to do it as much as of it async as possible.
Yeah, so we're sending a lot of questions. We'll also try to integrate that with Teams, Slack, and basically if there was a question to somebody, let's ask that. So we also try to build a map between the entire company, and we provide which team is responsible for what, which PM is responsible for what kind of domain, and basically if there was a question to that, to send that automatically. We are trying to achieve that as well. But it's a little bit slow, unfortunately. So we're still working on that because this basically means we need to be able to do it. Oh, there was other questions. What was that, Rubo?
You gotta have so
there was 2 questions.
different sessions, different questions. So in
Okay, let's stop here and continue with the questions from the room. Any other questions? If no, thank you so much. Oh, yeah, go ahead.
We started with 8 agents, everyone had a different role, and you mentioned we can maybe add 9 agents for databases.
Yes?
What is the optimal number of agents? Where do we get diminishing returns?
Depends, is the correct answer. So we have how many agents right now?
it depends on what you're building. I think we have 108 right now.
Depends how you use them and how they're collaborate. So for example, for my team, we have custom commands with custom agents because we're doing very specific work. So we're building low latency applications, so it's totally different. So depends how they collaborate and things like that. There is no specific number. There is just no specific number.
So if
You need to try it and test it.
if you're building a pet project, you can probably go with these 8 plus maybe a data layer expert. But
And
for-
some other architects as well.
security
Probably
architect.
Java expert would be good agent, not just a backend.
Another question here.
Yeah.
Yeah. So do you ever try to limit the size of your skills, how big they are, or optimize it?
They're
Because I've
limited.
seen them being
They're limited by the quadcode itself. So if you have very big skills, it's going to provide you a message that you need to limit that. It's around 40 kilobytes or something like that.
It's 40K in tokens, I think.
Yeah, but they also provide you skills how you can build skills.
So you don't specifically try to make them as small as possible.
No, we try to make them explicit enough, and also in them you can link them to the other documents. So you don't need to provide everything in one skill file. You can add link to other files if they need it. So you can tell them that here is how you can build a thread pool, for example, or something like that, and basically provide them external file with that information. So not everything should be live in those MD files.
One of the big anti-patterns is actually either CloudMD or AgentsMD becomes like 5,000 lines. That's actually one thing we mentioned already. It's not the right amount of context because CloudMD is loaded for every session. You want a couple of hundred lines maybe with links to other relevant files. The way we usually structure it, CloudMD is the entry point. It points to relevant architectural documentation, let's say an architecture MD, which is again an index of a lot of other documents, including ADRs. This points to basically all of the relevant parts of documentation that the LLM can read and analyze. And it also lays the ground rules. So that's usually enough to do in a couple of hundred of lines in the root.md file.
Okay, is that answer your question?
Yeah, I have one more. So let's say you have those extra files like thread preview or whatever. So how do you store them and tell the agent to refer to them? Is this just in that CloudMD or is there a specific?
We just provide them, we provide a path to that file. In the skill or comments or agent, we provide the link to that path and basically provide, if you need to do something, read that. This is the way how you should do it.
Yeah, again, if you want to go very deep and you're not necessarily building with Claude, there are many ways to do it other than text files. You can, I think the latest one is people keep using Obsidian to do this. So it's again, it supports Markdown. It has graphs and links between the different files. You can also just do a database, right?
Okay, any other questions? No. Thank you so much, guys, and we hope that you enjoyed that workshop.
Thank you. Cheers.
I don't think so. Now it is? Perfect. All right. Good afternoon, everyone. Happy to have you all here. It's a small room, so if you have any questions in between, just raise your hand. We got plenty of time anyway. They did ask me to use the microphone, because then people on the recording or the live stream can also hear your question. Right? Welcome, please have a seat. We just started, so we're just in time. All right, this will be a deep dive session, so it won't be a hands-on workshop session, but it'll be mainly me talking about stuff. But to make it a bit more interesting, we'll also do a lot of live coding, live demos to show you how it actually works, but you won't need your own laptop or MacBook yourself. All right, today, this afternoon is going to be about concurrency crossroads, how to choose between reactive programming and virtual threads. And to get a bit of a baseline, is anyone doing reactive programming right now? One or two, maybe, 3, 4? Okay. And who is already using virtual threads in production? A bit more already. All right. And who has used Quarkus before? Also a few, so that's good. I'll cover some of the basics as well, but the demos are going to be mainly with Quarkus. So what you will get today. Number one, why is blocking the baseline and where will it hurt? Reactive, what does it fix? And what does it cost you at the same time? Then we're going to dive into virtual threads, the trade-offs, and I'll already spoil you a bit, is not a fix for everything. Then number 4, structured concurrency. It's still not ready yet, it's still in preview, but we'll show you a bit where it is right now. And in the end, by the end of today, you should know what to pick for your current or for your next project. And it's a concurrency talk, right? So it's a fair question. Why not single-threaded? Yes, a fair question, but it's a concurrency talk, so we'll do multiple threads today. So, who am I? My name is Willem-Jan. I'm a software engineer from the Netherlands. I live in Delft and I work in Rotterdam for Lunatech. We do JVM consultancy, AI, of course, because everyone does AI. And I've been doing this for over 10 years now on the JVM. When I started my career, I was mainly doing this in Scala. I learned that in university, so I did functional programming, reactive systems with Akka and Play. And then when Quarkus came out, I transitioned more to cloud-native stacks with Quarkus. And of course, we integrate AI systems with that as well. Today's agenda. We'll cover the introduction, then we'll dive a bit into blocking I/O, so the current state. Then we'll show you how reactive programming works. Then we go into virtual threads. I'll cover shortly Kotlin coroutines, but it's not the main subject of this talk, but I'll let you know what's out there. Then we're going to explore structured concurrency. Where is it now? What does it bring to you? Then we're going to compare the Quarkus ecosystem with the rest of the JVM ecosystem. What do other frameworks actually do? We'll touch a bit upon to performance, and in the end, show you some comparisons and conclusions. So for an introduction, I digged up a bit of a history. And this is definitely not going to be a history lesson today, but it's just to give you a bit of insight for the people who haven't been on the JVM for too long, to show you what was out there in the past. Well, obviously in 1997, I wasn't programming yet. Has anyone there used green threads? Now, people normally don't want to tell you that because that tells your age. but there will always be a few people in the room that actually worked with it, but I never really did. Then a year later, they started replacing the green threads with native platform threads, and they became the default on JDK 1.3. Then later, we needed some more primitives to do proper concurrency. They came up with the fork join pool and the fork join framework from Douglia. That was all great, but then I wanted more performance. Then they started the Reactive Streams initiative around 2014-15 to build reactive systems with RxJava and Project Reactor. Sorry? Yeah, exactly. So this talk only covers the JVM, but indeed they stole some ideas from other languages and frameworks out there. Yeah. Yeah, that came a bit later indeed. Then in Kotlin, had a preview with coroutines, and it has been stable since 1.3. And then people always kept asking, what will the JVM, what will the JDK do? So they've been talking about virtual threads for ages, and in 2023, it was released to the public with JDK 21. Then we had some troubles with virtual threads, where we had synchronized pinning, and we're going to see that in detail later today as well. Yeah, I can basically skip that bit because it has been fixed if you're on a modern JVM like 24 or 25. Then the current state of today, we have the structured concurrency, which is still in preview. Even for JDK 27, it was now accepted as yet another preview. And why do they do that? They keep on changing the API bit by bit, to get some feedback. So it's already in the 7th preview. And otherwise, if they would bake it in, I don't know, 5 years ago, they couldn't really change it. So they kept it preview for a long time. So if we have a look at 3 threading models, this is from the Oracle Solaris multi-threading guide from back in the day. On the left, we have the many-to-one, where we have green threads, and this is a simplified version. But basically, in your Java application, you would have some threads, and that will get mapped to one actual thread in the kernel. So it was a bit of poor man's concurrency, but at least you could manage some threads on the JVM. And that was back in the day when you probably only had one CPU or one core. Indeed, you only had one core, so your application had to do all the multiplexing because, well, the kernel didn't really have more cores to multiplex it over. Then in the middle, they started introducing platform threads, where we can map a thread in Java directly to a thread in the kernel. And that's where we have multi-core processors, etc., to leverage that. Then in the end, we now go to virtual threads, where we have the many-to-many model, where we have many virtual threads in your Java application, so in your runtime, mapped to a whole bunch of threads in your kernel. So this is a bit of a simplified overview, but it gives you a bit of direction where we went. So we started from just one kernel thread with some green threads in your runtime to one-to-one mapping, and now we can have all the threads that you want. So that was the history lesson of today. We're not going to look further into the past, but we're going to see where we're at now and what we can get in the future. So if we talk about I/O, I/O is everywhere. So if you're a pure functional programmer, your program does some computation, but it doesn't do really something useful because you can't interact with a file, you can't interact with a database, you can't interact with the network. So for a business application to do something useful, we typically need some form of I/O. So calling a remote service, calling a database, writing to a message queue, doing something with a cache. Of course, you have to mention AI, so calling an LLM is also I/O. And occasionally, you need to do CPU work as well. So what's then blocking I/O about? Every thread issues a request, and then when it calls a database or does some other I/O, the thread just parks and waits for the database to respond. Mostly that can be pretty fast. But you can imagine if a long-running query of your database is overloaded, the thread is going to be there sitting idle, doing nothing, have the memory reserved, and nothing productive happens in between. I mean, the thread is doing nothing, so it could actually do some CPU work, some computational work, but it can't because it's blocked. Well, that's what we've been dealing forever with. So what do they cost? Each Java thread wraps to one OS thread, and roughly, depending on your OS and system, maps to 1 megabyte of stack memory that you need. The creation and all the context switches have to go through the kernel, because if we look at, again, at this diagram, if I have platform threads, is the kernel multiplexing that back and forth to schedule your work. And the OS scheduler takes care of the scheduling, so it decides when your thread will run. For a practical capacity, you can have, on a modern machine, a couple of thousand, but if you want to have more of those, it will blow up, you don't have enough memory, it doesn't work. So you can't have millions. So how did we deal with that for the past 30 years? We used a fixed size pool for everything. So if you're using Quarkus or Spring, you typically have some pool of workers, you have some pool of request handlers, you have some pool for database connection pooling, and we tune those pools typically. Because the sizing is guesswork. If you're in development, well, it works great, you go to production, it blows up, it doesn't work, you get timeouts all over the place. So, well, you do a quick and dirty fix on your Tomcat server, increase the number, and then magically you hope and pray it works, and then you hit another bottleneck and you have to tune it again. So what we typically do, we do some performance testing, tune the thread pools, the database pools, etc., before we go really to production. Has some downsides. If you have an undersized pool, we get queuing and we get a lot of timeouts. If you have an oversized pool, well, we just have threads allocated doing nothing. And a thread means a bit of memory as well, doing nothing. So both things are bad. But we've managed for the last years to do this efficiently, and everything still works. And then the number of threads becomes a limiting factor long before we hit the CPU or the network really becomes the limiting factor. So if we look to a typical web application, let's say I have a simplified application and I just have two platform threads to handle my web requests. So if the ping request 1 comes in, platform thread A handles that request, maybe does some JSON processing, some bean validation, and then calls a remote service. When it's calling that remote service, that needs a bit of time to respond to your request. You see the jigged line, it does nothing. So if request 2 comes in, it has to be assigned to platform thread B, and there we have the same issue. Now when request 3 comes in at the same time, there's no platform thread available to handle it, so it gets scheduled later by the framework, and that's why you might see high latency or in the end timeouts, because if the requests keep on piling up, you don't want to have an endless queue of requests that you want to handle. So typically there's some limit on that in-flight requests, and then yeah, you basically just give timeout errors to the client. So for this, I came up with a small demo application based on Quarkus. So in the middle we have our coffee shop, and then we have a remote coffee machine. And this remote coffee machine always needs to be turned on, warmed up. So typically if you make coffee, you have to warm up the coffee machine, and then you can make your coffee. So there's an artificial delay in there. And if you ask for a coffee, it takes a bit of time before the machine is warmed up, and then we'll actually start making the coffee. And then you want to, as a coffee shop, keep track of your orders that you've been making during the day. So we also will store all the coffees that we've made into a database. The implementation is pretty stupid. So if I want to have multiple coffees, we simulate that we start up the coffee machine again and again, and then we stop the coffee machine. So every time you make a new coffee, there's another delay. Let's see. Yes. So for the, sure, it doesn't share the right screen. That's better. All right, so I generated a simple Quarkus application from code.quarkus.io. It's a bit like Spring Starters. You just select the extensions that you want. So I selected Hibernate, Postgres, etc. You can see the list here, what I all selected. Generates me a dummy application. And then I built my little coffee shop into this. Then it provides this nice web UI of extensions that I've enabled. And extensions can contribute with something useful. Machine. Make it a bit bigger. And here you see a default mapping that if you want a coffee, it gets you back a coffee successfully. But the crux is here. It takes it 3 seconds, so there's a manual delay in there to simulate that the coffee machine is warming up. So that's on one hand the WireMock implementation, so that's our external coffee machine. Then we have a simple database view where we just persist the beverages. Well, there's nothing in there yet because we haven't made a coffee yet. And if we then have a look, export. So let me show the code first, that's easier. So we have a simple bean here, a blocking bartender, which get injected a REST client, which is our coffee machine connected to our WireMock instance. And then we just call the coffee machine and give back a beverage. So the bartender just asks for a coffee and that's it. Then we have a simple DTO here, a simple entity. We use a panache entity with Quarkus, and that provides you some easy accessors, a bit like Spring Data if you're used to that. Then we define a simple repository where we can persist a beverage or we can persist a list of beverages. And then we can just inject that into our resource. And then we have a simple get endpoint where we say, get me a beverage, save it to the database, and give me back the coffee to the user. If I then execute that, blocking simple, it's going to take those 3 seconds because there's the manual delay in there. And then we got back our blocking coffee here. Plain, stupid, simple. It's just a REST resource with some servers injected with a REST client. Yes, the blocking simple, just a blocking call. If we then have a look at what it did, that gets spawned on the executor thread, so on the worker pool in Quarkus. Let me make it a bit bigger actually. And well, it then is warming up the coffee machine, takes a couple of seconds, persists the beverage, and give it back. And this all happened on executor thread 5. So it's you have your easy mental model. A request comes in, one platform thread handles the request, does the JSON marshalling, does the external calling to my WireMock instance, does the database call, and also returns back the response to the user. So you can, if you reason about it or want to debug, this is easy. This is what we're used to. You can just trace it through the application, hook up a debugger, will just work. If we then want to do sequentially, so we want to have some coffees for our friends, we can execute it sequentially. We ask the bartender 3 times for a coffee, compile a list, and give back the list. If we then do so, as you can see, every 3 seconds is now warming up the coffee machine because it's a pretty stupid bartender, a pretty simple coffee shop. So it has to do one by one, and it gives you back the result. Well, that's not really concurrent, so we want to do it in parallel. If we do it in parallel, we just inject an executor, submit this task to an executor, and then we can do all those things in parallel. So if we do this now, you see that the coffee machine is warmed up at the same time, 3 times after each other. And that happens all on different threads as well. So the initial request was handled by worker thread 5, spawned 3 new tasks on 3 other worker pools. They picked it up. So you see thread 8, 7, and 9 doing some work. And then when it goes back to the user, we're back on thread 5. So they joined back, and then we're done. Let's see, what else did I have to show? We can forget about this one. We can also have a flaky bartender, so have a look at that implementation. And there we randomly throw away the coffee. So it makes a coffee, and instead of you giving you back a coffee, you have a chance of roughly 50% that the bartender just throws away your coffee and doesn't give you any coffee. This to simulate some failure midway. So if we execute that one, so you see that it's warming up, but then something blows up in the middle, and we don't get back our coffees. So if we have a look at the response, the coffee machine broke. Well, there was a chance of 50% per coffee breaking, but in this case it threw away all the coffees because we didn't get any coffee at all. So even if it was making 3, 1 failed, you don't get back the other 2. Well, there are some ways to handle that with failures, but it keeps on brewing coffees in the background, and then when it returns it, it throws them away anyway. So that's kind of bad. But this shows you a bit of the primitives that we can do with blocking I/O, that we can do it sequentially in parallel, and that we can fail fast as well. Yes. And this is just to set the baseline for everyone. This is what we're basically writing when we're writing our simple CRUD applications with Spring or Quarkus, whatever framework. You typically write it something like this. You call a couple of services, maybe you use an executor service to do it in parallel, and you give back the work. However, if you get a lot of load, it's going to be difficult to handle the load, so we have to tune those thread pools again, those database connection pools, web request pools, to get a bit more performance. And if we want a bit more performance, we basically have to grab a new server from the basement or from your cloud provider to plug in some more CPU or memory. Or use single threaded, yes, of course. Yes, but the threads that I'm talking about indeed are the platform threads right now. So then people wanted to do something new. They wanted to use the hardware a bit better, because they were thinking, well, if all those threads are doing nothing in the meantime, that's a bit useless. I want to squeeze the most performance out of my hardware. That's why they came up with reactive programming and reactive systems. And if we look at the reactive manifesto, the thing is we should always be responsive. So when a user does something, we should always be able to respond. So we should respond in a timely fashion under all conditions. Even if the load is high, we should be able to give you a response. Also, it should be resilient, so stay responsive in the case of failure. So do fail fast or error out fast and try again with retries. And it should also be elastic to stay responsive under varying workloads. And how do you typically do that in those systems? To make everything message-driven with asynchronous messaging. So you have loose coupling as well. If you see that in a diagram, people probably have seen this type of diagram before, where at the bottom we have the message-driven, that makes sure a system is resilient and elastic, and therefore the system can be responsive in all times to the user. So when we're doing reactive programming, we should never block the event loop. So we use an event loop to handle all those events, to handle those asynchronous events, but we should never block the event loop. We typically, if you have event loops, Quarkus by default will spawn the same amount as event loops as the number of cores you get allocated on your machine or in Kubernetes or to the JVM on your system. So in this case, a handful of threads, it's hardly readable on the TV, a handful of threads serve thousands of connections. So we don't have a thread per request anymore, but we just have a handful of threads handling thousands of connections as fast as they can. We have tight CPU cache locality, so we don't have to do context switches all the time. We just can keep it on there. With reactive system, back pressure is explicit. So if a consuming system says like, hey, I'm overloaded, I can't handle all the stuff, we have back pressures in reactive system, so it will slow down the producer instead of overwhelming the consumer. To programming in that model, we have to do composition via operators like map, flat map, zip, retry, timeout. And that's a bit more difficult to program with, but we're going to see that later. So what it costs you at the same time, if you do something like this, nothing can be blocking in the middle, because then the entire chain will be blocking. So the entire stack must be non-blocking. So your connections to your database, to your message queue, etc., should all be non-blocking. Then if you look at stack traces, because those event loops interleave a lot of work in between, it's really hard to get a proper stack trace out of your system when something goes wrong or you get an exception. Because normally you follow the call graph and you can compute a nice stack trace, but here they're mostly useless if you try to look at them. If you have a thread local or an MDC for some context with tracing, you need deliberate propagation. So in Quarkus, they came up with a context propagation extension where this is handled for you automatically. But there are still cases where you really need to think about the thread local and the context to pass it along correctly. Because of all this, debugging is non-trivial for new people, because if you hook up a debugger in there, it just blows up, it doesn't really work. And what is also a lot of times different, the team has to commit to the paradigm. So if you have a team of people who are functional programming enthusiasts, it's probably easier. But the problem is a lot of people then do different functional programming styles in the same application. So for a newcomer, it will be really hard to copy and paste the controller and implement his own work because the other controller looks different again. If we have our simple CRUD controllers with Spring Boot or Quarkus, it just reads sequential, you copy paste it, adjust it, it works. But here, the team really has to commit to the paradigm. So, how does non-blocking I/O look like? In this case, we have a simple system with just one event loop, and an event loop is still simply a platform thread. But it wants to eagerly do some work. So when request 1 comes in, it again does some JSON processing, then calls the remote service, but it's not going to wait there and do nothing till the remote service comes back. It can handle request 2, 3, 4, 5, or another 1,000 requests, and handle those in between. So in this way, we have just one event loop thread, which maps to a platform thread, and can handle 100 or a couple of thousand requests while waiting for some remote services to be executed. Has a bit of a drawback, right? Because now everything is mangled together. So if you want to do stack traces, debugging, this is already a bit more difficult than having when you have a thread per request, and it was nice and easy to follow through. So how does the event loop thread do this? So we now visualize it like this. Request 1 comes in, does some work, and then it's going to schedule some I/O somewhere. And that's just waiting for a database or a message queue to come back. Then request 2 comes in and does the same. And then the continuation of the scheduled request 1 comes back, and then it can handle that, process it, and give it back to the user. And so that's how we can interleave inside each other. And this way, if you have an event loop thread, which is a platform thread, it's always doing something. Because it eagerly wants to do something, so it's always processing events, given if you have events coming in, like requests. The nice thing is, what I mentioned before, said that you had to do reactive all the way. There is a middle ground. In Quarkus, you can actually do both at the same time really easily. So you can have an imperative endpoint with a worker thread from a pool, blocking database, blocking HTTP client, etc. Then you can have in the same application or the same REST controller have another endpoint, which is a reactive endpoint, which runs on an event loop thread, doesn't block, and uses non-blocking clients throughout. So if we visualize that, basically we have an event queue somewhere. So we have incoming requests that need to be handled. We have a bunch of I/O threads or event loop threads. They're eagerly looking for work to do. They can either find a handler and dispatch it, so they can handle the event, do some processing, and be done. But they can also switch off, so they can also hand off if it notices, hey, this is a blocking JDBC call, I shouldn't be doing this on my event loop thread, and it detects this based on the types and the usage what it's doing. It will offload it to the worker pool, so we have a bunch of workers configured in your typical application, and this one will handle this one blocking for you. That's how it can mix and match. It can delegate the work to worker thread for you as well. But it does require a context switch. So to do reactive programming, we need some extra goodies. In Quarkus, they came up with Mutiny. It's a standalone library that you can use in Quarkus, and where you have a uni and a multi. But of course, you can use your good old Java concurrent package with a completion stage, but the composition is a bit more difficult. So that's typically why you would use Mutiny, because composing all those futures is a lot easier with Mutiny. Then from React to streams, you can have a publisher for doing streaming data, or you can, of course, use your Kotlin coroutines in your application as well. And those you can all mix and match in the same application, actually. For the people used to doing reactive stuff in Spring, it looks a bit like a mono and a flux. So if a uni emits one item or a failure, so it's like a future, so you get something back in the future if you subscribe to it. It might be null as well, because, well, we're on the JVM. And it's similar to Reactor's mono. So we typically do this for an HTTP call, a database lookup, a cache hit, etc. Then we have a multi, and that's for streaming. And a multi is just an unbounded stream of 0 to n elements. And then either can complete or it can fail. And this implements the reactive streams publisher and looks a bit like a flux. You would typically use this for Kafka streams, server-side events, streaming file lines from gigabytes of log files or big data, for example. You would typically use a multi. What my naive self did a couple of years ago, if I would get a list of records from a database, I was like, hey, this looks like a stream. I'm going to use a multi for it and pretend that my database is streaming. That doesn't really work, because your JDBC driver or your underlying database driver, even if it's reactive, is not really streaming. It's more like a future. So you shouldn't treat it as a streaming data source. Kafka streams can be a streaming data source, but your database typically is not a streaming data source. So now they changed the API in there a bit as well to make it easier to work with. That you really use a uni of a list of entities and not a multi of entities, because that doesn't really make sense for this use case. Because your database is not going to have things like back pressure with reactive streams. So how do we code with this? This is just a simple example. So we create a uni from somewhere. Typically, the framework provides this, where we do a database call or a REST client call. Then we can say, when we get this item, we can transform it. So we can take the item and append the string hello. And the onItem.transform can also be a .map. So if you're more used to functional programming languages like Scala, it's simply .map. But it's a rather expressive API, and it allows for nice auto-completion as well. So if you do .onItem, it will show you all the things you can do when you get an item. Well, then we can delay it. So like we saw in our example with our coffee machine, we can delay our items. And in the end, we should subscribe. If we never subscribe, we just register this uni or future, but no work will be done at all. So if you never subscribe to a uni or multi, no work will be executed and you get nothing. But typically, when you put this in a REST endpoint, the framework around it will subscribe for you, so you don't have to do an explicit subscribe. If we then have a look at a multi, there we can have multiple items or none, where we can do an onItem transform as well. We can do select the first things. If we have a failure, typically if we do reactive streams, if we get a failure midway, we want to recover because we want to be resilient. And if the Kafka streams do fails due to a network latency or whatsoever, you don't want to fail the entire stream, but you want to recover with something. And then again, you should subscribe to the stream, because otherwise the stream doesn't get executed. Then in Quarkus, we have a whole ecosystem of reactive extensions. So Quarkus REST supports it, where you can mix and match them. The Quarkus REST client also supports both the blocking and the non-blocking way. Then you have a dedicated extension for Quarkus Hibernate Reactive, so you can do reactive Hibernate in Quarkus. And nowadays, in modern versions of Quarkus, you can even mix and match Quarkus Hibernate with Quarkus Hibernate Reactive. So you can have both reactive and non-reactive Hibernate in the same application. You can have Quarkus messaging for interacting with Kafka or MQTT. You can have a non-blocking Redis client, and the list goes on and on and on. So sometimes you need a dedicated extension, like Quarkus Hibernate Reactive to get the reactive version. A lot of times you can just use both APIs when you enable the extension. So let's see a bit in the code how that would look like. Let's close the blocking. So now again, we have our that doesn't work. Yes. So now we'll have a reactive bartender, and now the return time is a uni, so a future of a beverage, where we say to the coffee machine, brew async. So if we have a look at the implementation, you can see that here we have a REST client registered, and Quarkus then generates the implementation for you. So you just have to put on the annotations where you can find this interface, and then it will generate the implementation. Then we have the normal response, and we have the async response where it gets back a uni. That's the only difference, actually. Now, when we get back that response, we can map it, but as you saw before, we can also say on item, and on the on item, we have a whole bunch of methods that we can actually do. We can replace it with a transform. So the on item transform is really the same as the .map here. No, the flat map will be transformed to uni. So then this thing in the middle would be a uni. Now, but you can as well. So you can also say flat map here, if this thing will get a uni. So you can have both. If, like I mentioned before, if you're more used to the functional paradigms need of map and flat map, you can use them. If you don't want to use them, you can also use the on item and then get this expressive API where you can really mix and match. And it's a bit more easy to discover for newcomers, I would say. Or if you're lost in between, if you just do on item, it gives you all the things you can do with this. Yeah, that's a good argument as well. I'll get back later to that in the presentation as well about AI. I will confuse AI as well, yeah. Reactive programming with AI is also a bit more difficult. I would say AI is a lot better at doing blocking code, typically. Yeah. Yeah, it's going to be tricky indeed. So if we have here a Panache entity, it's now a reactive Panache entity. The same for the repository, it's now a reactive Panache repository. And then the return times will be uni of something. So that's the only difference. The package name changing to Panache reactive, and then I get a uni back. And then those can coexist in the same application. The blocking package and the reactive package are still in the same application. If we then have a look at the resource, we can still inject. And here we now see the return type. But we see we never subscribe. So I can call subscribe here. But I don't really have to, because Quarkus will do this for you automatically. If we have a look at the examples, if we say reactive single, and here's already a gotcha. Reactive programming is not going to make this faster somehow. We still have to wait for 3 seconds for the coffee machine. We can just schedule a lot more coffees on the one thread instead of needing hundreds of threads. That's the only difference. We can, the wait is not magically going to be less, but we can schedule a lot and handle a lot more requests at the same time before overloading our system. So if we now have a look which thread handled this. So here we say it's on event loop thread 5, so it's going to make a reactive beverage. It's going to warm up the coffee machine, going to persist the coffee machine, and actually give it back. And this all happened on the same event loop thread. And that's to make sure that we hit the CPU cache efficiently. Because if this midway will be to another event loop thread, it has to move around some bits and pieces for memory in the cache, so it's more efficient to schedule it on the same event loop thread. But it can, of course, if the system is really busy, decide to schedule it on a different thread. But typically, we would keep them as close as possible, because then we don't have to copy over stuff from memory to another bits in the cache for the other CPU core. Now, then we can do this sequentially as well, of course. Let's see. And now you start to see where it hurts, right? If we want to do this sequentially, we're going to get this ugly nested flat maps. And 3 is not too bad, but I've seen way worse in production code. This is still easy to look at. But if you put a debugger in, it's really hard where it has to jump and it can't keep really track and stack traces as well. But this is how you would do it. If I get 1 coffee, then call flat map. So this is the on item. We can replace the flat map also with the on item transform to uni. That will be equivalent. So we expect something to get a uni out there. This is how you would typically do in functional systems. Also, if you do functional JavaScript, you get all those nested blocks of code. Let's revert this. If we then say do this sequential. Sorry? You could, but this is the proper way of doing it, yeah. And this, here you see it's event loops thread 6, doing all the work one by one. Well, that's not really useful. So again, we can do it in parallel. And here we have some nice primitives. That's where then Mutiny shines a bit more. You can get some nice utility methods. So here I just define my uni, so I define my futures, and they don't get executed yet. It's just defining I want some coffee in the future, maybe sometime. Then I can say join them all. So go get them all in parallel and collect the failures. So instead of on the first coffee that goes wrong, throw away all the other coffees, I'm eagerly gonna get all the coffees, but also gonna collect the failures here. Yeah. Yeah, you can optimize this a bit, but for readability, I kept it simple. But you could, that's again then where functional programming comes in. People then get creative to get it squeezed on one line, and then nobody understands anymore what the system does. We always did the running joke at our company with Scala code. It's like, hey, I have this snippet of Scala code. Who can rewrite this in less lines, or who can rewrite this the shortest? And you get crazy solutions, and then in the end, nobody knows anymore what it does, but it does work because it compiles. So. All right, so if you do them in parallel, you can see it's still event loop thread 5, handling all the stuff, scheduling all the futures. And it's still the same one because it came in on virtual event loop thread 5. So all the order work is going to be done there as well. It doesn't need to spawn more threads because it just schedules more events that are handled by the same event loop thread, because then we benefit again from the same CPU cache locality. So it's actually in Quarkus. Well, we have Mutiny, the programming language, programming library, and then under the hood it uses Vertex, and Vertex takes care of scheduling this together with Netty. Yeah, Vertex and Netty really handle the low-level scheduling for you. And if we then go in here, so and here you have also other primitives that you can call, right? So before we did collect all failures, but now we can also do fail fast, so we can get the same thing again. Sometimes for a use case, it might be beneficial if you do a fail fast, because if one of the things fails, I can't be bothered to do the other things, so just cancel them and stop doing them. Yeah, so the remaining work. So for example, if the join.all will schedule beverage 1, 2, and 3 all at once, but if then beverage 1 for some reason fails, it's also going to cancel out the unis for beverage 2 and 3. so that it doesn't do useless work. Ah, great. I'll try that. Marble diagrams, you said, right? Thanks. So if we have a look at the gotchas, one thing already said, blocking the event loop thread. We should never do any blocking work on an event loop thread or IO thread. So we shouldn't call thread.sleep or anything on them. Context propagation is hard, so we can use the context propagation from smallRye as an extension in Quarkus, so that handles automatically. If you ignore back pressure with a multi, you can still get an out of memory exception. So set an overflow strategy explicitly. What should happen if my other downstream system can't handle my messages? Where should they go? Should I just discard them? Should I write them to disk? Whatever. But that system itself is then responsible for defining an overflow mechanism. Well, debugging already mentioned. Transactions are difficult as well in reactive systems. Luckily, Quarkus makes it quite easy. You just still slap on the transactional annotation and it works. But you have to be careful what happens when. And then again, the operating learning curve, I would say with Mutiny it's not too bad. But yeah, the discussion with map versus flat map versus concat map or transform to uni and merge, you really need to start learning all those terms and maybe settle on a strategy that you use within your team. Then talking about transactions, a couple of years ago we were hit by this. We built some internal application that would aggregate some data from different systems. So imagine that we had an HR system for all our employees. We had a Google Workspace directory. We had a GitHub organization, and we wanted to pull in all the information, persist some stuff to a database. And then it didn't work. We were like, oh, it compiles. Normally with functional code, well, if it compiles, the compiler says, yes, it should be good. But in this case, with hibernate reactive and transactionals, it can be really difficult. Now, it's not per se too slow. Let me share that blog post. I'm not going to go through the entire blog post. I'll share that shared as a resource in the presentation. So here we say we evaluate unis in parallel. That's what we did before, right? With combine all. Where we combine two service calls in one and run them at the same time. All you say, nothing's bad, but let's see. Yeah, sorry? Yeah, I think so, yeah. I think it will be a fault or a fault left, yeah. Yeah, good question. So it's going to execute because of the join combine all, it's going to spawn them in parallel, then combine them and have some operator to combine all the unis. So that will be a fault in functional programming indeed. You say this worked great. If I'm calling external APIs, I can do this safely, right? If there's just REST clients, I can just spawn a whole bunch of unis, call 20 REST APIs, works. Then we have hibernate reactive unis. There's this big thing, big yellow warning in the docs, but yeah, who reads the docs? We didn't, or at least not this bit, but it explicitly mentioned the session is not thread safe, or they call stream safe. So you might hit things that are impossible to debug or even to detect. But you can get wonderful errors like session is closed. So some other uni already closed your session. So the other uni that was executing in parallel took a bit longer, wanted to write something to the database, but the other uni already closed your session. Nothing happens. And the ones I love the most is illegal pop with non-matching blah, blah, blah. And we had no clue what that meant. So we had some fun with this. And it's mentioned in the docs, again, not to blame people here or say that it's bad, but we didn't properly read this. That's probably where you're gonna hit as well, because you can write it compiles, in your basic test locally it works, and then in production it blows up in your face. They explicitly say doing a session or sessioning operations, you shouldn't do concurrent opening those sessions, so you shouldn't do them. So the poor man's solution is saying, combine them using concurrency of 1. So yeah, it's sequential again. So it still writes as, you can write and read it as parallel code, but the concurrency says do this one by one on the same thread. That fixes the issue. That works, but it's still not great for throughput, right? But at least it fixes your exceptions and it works. Then we had some issue with GraphQL. If you do GraphQL queries, it fans out to different service endpoints to get some data for your GraphQL data. And it's the GraphQL engine deciding to combine unis whenever it wanted. So we were not in control of those unis, so we couldn't really do anything about that. So we couldn't slap on this using concurrency of 1. So what do other libraries do? For example, Doobie and Scala. Doesn't give you for those it gives you a dedicated type for this. So instead of giving you an IO type or a future type, it gives you a connection IO type, which then has a bit of information around it if you try to combine them that you can't do it. So the compiler will say no. Unfortunately, we don't have that. So we did another workaround where you can build your own mutex with a semaphore. I'm not going to go into all the details, but there's a workaround where we had an interceptor where we, with a semaphore and a lock, and basically you can only do one by one. So you to write to the database. Yeah, well, when we go into the database, then you do it really one by one, but the rest of the code, you can just write whatever. You can combine database calls with REST calls, you can combine all the things together. But when we're writing to the database or reading from the database, we're gonna do it one by one. Only one unit can acquire a lock or a ticket from this lock, so this one can actually do some work, gives back the ticket, and then the next unit comes in. Depending on your use case, if you want. I think so, yeah, but depending on your use case, it might not be possible. Or you want to have consistency, so you want to have your reads transactional as well. So that was a bit of a story that we did before. The implementation is straightforward. An alternative approach is duplicating the vertex context. There you duplicate the session, and then it will get a unique session in there. But it requires a bit more plumbing as well. Yeah. But then it happens in its own transaction. So if you start duplicating the sessions, they all get their own new transaction. So if one rolls back, one might be committed and one might be not. Depending on your use case with eventual consistency, might be fine. If you're working with financial data, maybe not so. So there's some gotchas on how to handle this. Yes. And again, you do get great performance, but you do have to watch out a bit for all those gotchas you get on the way. And it's always not so obvious what is really happening, because if you see this illegal pop, you have no clue what was happening in your application. At least I didn't, and my colleagues also didn't. So it took us a bit of time to get there. So this is where we came for, virtual threads. People have been talking about virtual threads for ages. When they ditched the green threads, they wanted something that they call virtual threads with Project Loom. So they did multiple previews, and in JDK 21, we finally got virtual threads. So all good, you would say. Well, there are some gotchas, because we had to synchronize pinning, which we'll show later as well. But the main pitch is that we can write plain imperative code again, with reactive level scalability without doing the rewrite to reactive programming. So what are virtual threads? It's just a Java long thread, but in this case it's scheduled by the JVM. The JVM mounts it onto a carrier thread, and this carrier thread is just another platform thread, because in the end Everything on the JVM is a platform thread that maps to kernel threads. And when it encounters some blocking operation, it's going to unmount it, park it somewhere, store it in memory, freeing the carrier, and then it can do some work. And the carrier pool defaults to a fork join pool sized to the number of CPUs. So it looks a bit like the event loop threads or IO threads that we had before. We had to have a handful of them. They do the actual work. They get scheduled by the kernel. So then we have continuations. So that's what underpins virtual threads. That's what allows you to do virtual threads. And it's a suspendable, resumable piece of sequential code. And Loom uses stackful continuations. And each continuation has its own call stack. So all the steps that we have sequentially before it, that's the call stack that we have. And that they're limited, so they yield in a bounded scope. So they won't yield somewhere else. And they will also be yielding exactly once. And then we can discard the virtual threads. So we're not going to reuse virtual threads. We're just going to spawn one for some task. When it's done, we're going to throw it away. This continuation that's underneath it is explicitly not public, but it's a JVM internal. So why should they be stackful? A suspend point can be anywhere in the call stack. We don't need function coloring. Think like suspend or await async from JavaScript. We don't need that coloring in Java with this stackful solution. And existing Java code, without you putting on labels like run on a virtual thread or make it a suspend function or async await, the same blocking code we can now just execute on a virtual thread. That's also what Spring did. You just put in your configuration, run on virtual threads, and all your REST controllers run on a virtual thread, and you didn't have to change any code. I'll get there later. But yeah, there's definitely not a one-shot approach to just enabling virtual threads for everything, but you can. Just saying that you typically, if you've done it correctly, you don't have to change any code. Yeah, you're gonna have some nice war stories probably of doing this, yeah. So I'm gonna show you some examples today indeed when you should not and when you should use virtual threads. For contrast, Kotlin coroutines are stackless, but they require an explicit suspend in this case. I'm not gonna go further into all the internals of the JVM. I'm just gonna see what is really useful for us and for us as developers on how to use them. I think there are some excellent talks from other people that are going to go really low level into continuations, etc. So when we have a virtual thread, the scheduler pricks a virtual thread, so with a whole bunch of virtual threads. The stack is frozen somewhere. It thaws the stack onto the carrier, runs some real code on the CPU. Then the virtual thread hits a blocking operation, so calling an external REST API. The JVM freezes that stack, puts it somewhere, copying those frames to the heap, and then it can be cleanly unmounted, and then this platform thread or carrier thread can grab another virtual thread, do some work with that virtual thread. And again, in here as well, carrier threads itself should not block, but it's managed by the JVM. But that's where pinning comes in. There, it could be blocked somehow because the virtual thread couldn't lift it out of there. But we'll see that later. So if we look at this image of the requests again, I would say it's basically an overlap of the two images we saw before. So we're going to have a whole bunch of virtual threads. So per request, we're going to have a thread again, a virtual thread. So we can have the thread per request model again. But we're only going to have one carrier thread. So that matches again with the event loop threads. The virtual thread 1 does some useful work, gets mounted by carrier thread that does the actual work. And then it can unmount it, grab virtual thread 2, do some work with virtual thread 2, and mount that one, and so on and so on. But the request 1 lives on virtual thread 1, and there it can actually do some blocking operations without really blocking actual platform threads. So what I mentioned before, it's a dedicated fork join pool with the number of available processors with a work stealing algorithm on there to efficiently, like event loop threads, do as much work as possible. You're going to have roughly 256 platform threads to compensate for all the other blocking work. But that's more details that we're going to cover today. There are some knobs you can tune for those pooling, but it's just more for you to be aware. You can tune how it works, but typically you don't really need to. So, what can be unmounted? What can the JVM actually unmount and put back on the heap? So stuff with sockets, with Java NIO channels, with files, for example, a thread.sleep. You can safely do a thread.sleep in your code now. Stuff like from the Java util concurrent package with reentrant locks, semaphores, etc. Completable futures, and synchronized blocks. So sometimes you would have synchronized blocks in your code. Before Java 24, that would also still pin the virtual thread to your carrier thread, but they now fixed it. At the same time, a lot of JDBC drivers were actually doing this. So they all, onto Java 21, have been fixed mostly and replaced by reentrant locks or semaphores. But in the same time, the JVM caught up, fixed it itself, so you wouldn't need the fixes anymore from the JDBC drivers. In 24, it's fixed. Now in 21, it's mostly the libraries that fix themselves. So in the hot pass of your code, it wouldn't really happen. But on Java 24, it was really the JVM that was fixed in there. So when can I still pin? If you do native method calls or use the foreign function and memory API, because then you're doing stuff low level, and then the JVM can't really see what you're doing. It can't do like a low level process, grab that and put that somewhere else. There, you can't really use virtual threads. Oh, you can observe virtual threads. There are a bunch of JFR events that you can monitor for, but typically you don't really need to. So if we go, what will be the benefits of virtual threads? They're really cheap. Go ahead. Yeah. Yeah. Yeah, I've seen something about async stack traces, but I can't remember if they already fixed it or in which JDK. But yeah, but there's some works indeed to fix that as well. Good point. So the strengths, you can have millions now instead of a couple of hundred or a couple of thousand. You can just spawn for everything and you can create a virtual thread, but never reuse them. So don't pool them, just use them once. And they're cheap to block. You have low overhead per thread. So the continuation is stored on the heap. There's just a small fraction of that continuation, and it doesn't allocate the full 1 megabyte for a stack frame. You have the same thread API, so the same Java API that we're used to doing concurrency. Some limits. They do not add more magic or more parallelism by default. So if, yeah, sure, we can have more virtual threads. We're not magically going to be handling 1,000 more requests at the same time because your CPU still needs to do the actual work. It's not going to magically make a computation faster. If you had a slow running computation, they actually needed CPU work. It's not magically going to make it faster. Might even make it slower if they have to do amount of virtual threads. Again, do not pool virtual threads, and do not use thread locals freely in that sense as well. There we have now scope values, and we'll touch upon those a bit later as well. So to talk about pinning, synchronized blocks caused the virtual thread to be pinned to its carrier, and that held the OS thread really hostage. So you had a synchronized block somewhere. It really would pin the virtual thread to the platform thread. It couldn't do anything in there usefully. So we had some JDK, so some JFR events or some JDK arguments, JVM arguments where you could say like trace those, find them where I use them in the application. You would hope you would find them during CI, but typically you would find out in production if you would hit those. Well, luckily from JDK 24 onwards with JEP 491, the synchronized blocks don't no longer pin the virtual threads. So we also don't need to trace them anymore. The JFR events stay for the obscure cases. You don't really have to replace your synchronized block with reentrant lock, just keep the code and be done. Again, native calls can still cause pinning, so be careful if you're doing that. So if you visualize this, if you have a carrier thread, which is a platform thread, it mounts a virtual thread, does some work, but it can't be unpinned because it's blocked by the synchronized block in this case. It couldn't unmount it. So that was the problem back then. They fixed this now, so we're all good. Thread locals with virtual threads, they still work. You can still use them. For some use cases, they're still useful. But it's really harder to work with. You're gonna blow up your memory of those with large values. And you also need to propagate all those values to your millions of virtual threads. So instead, they came up with scope values. They're, for one thing, immutable, which can be annoying, but it's really good, because then we can freely copy it to other virtual threads that are children of my virtual thread. And they're cheaper than a thread local, because they don't have to be mutated. And they're perfect for request context, your authentication principle, correlation IDs, etc. So on a modern JVM, prefer to use a scope value, where you could create one, and that scope value only lives for the scope of that virtual thread that was created. Then another big thing, what I mentioned before briefly as well, is CPU monopolization. So a virtual thread is actually doing some CPU bound work, so it's actually doing some meaningful bit of work. So there are no yield points. It's not waiting for Kafka or a database. So it really needs to keep on doing work. Now, this carrier pool is small, so only the number of CPUs you have. And then if we have a few CPU-intensive tasks running, I can't handle any other incoming requests anymore, because they're all doing something already. So how to handle this? You typically offload that to a fork join pool dedicated for that computation, and then it's again the OS and the kernel taking care of that scheduling for you. And so then you will have a bit more fair scheduling, so that your carrier threads can mount those virtual threads, handle requests, and do something useful with them, without the CPU work really bounding your application. So to make sure that we can still reply to a request. If you see this in action, virtual thread 1 comes in, does a whole bunch of computation. We're gonna need another carrier thread to do that work. And we're gonna run out of carrier threads, because if you only have 4 CPUs, you can only do 4 of those things. And if then a request will come in this case, request number 3, nothing can happen and the user gets a timeout again. So that's why we typically offload all the CPU work to a dedicated fork join pool, who's a lot better at scheduling all this workload. So virtual threads, discovering them. In dev mode, what we have in Quarkus is a nice thing. A virtual thread typically doesn't get a name, because they live so short, the JVM doesn't bother giving them a name. It's been on, with Kubernetes, with cattle versus pets. On a farm, you also not gonna name every cow, but maybe if you have a cat at home, you would name it. The same with a virtual thread. We're not gonna bother naming a virtual thread. But in Quarkus, you can have the naming by default its own, so you can easily trace what's going on. So that stack traces and thread dumps identify really where you're at. So it makes it a bit more easy to debug. And you have a JUnit extension where if you were still on Java 21, where you could detect the pinning, the virtual thread pinning, and that does this on basis of a JFR event. So it runs your test maybe for some REST controllers, and if it emits some JFR events that something is pinning, a JUnit test would fail. So you can set some guards around it, so like, hey, even if you're now on a modern JVM, so like, hey, I do some low-level stuff, I know that it pins once, and I think that pinning is fine. You can set a guardrail so like, you only pin at most once, and if it does it now suddenly 10 times, you know you've broken something. It's mostly that you don't really need to worry anymore about, because, well, the pinning has been fixed. This is basically a summary of what I said. If we then have a look at the code is going to be quite simple. Yeah, that works. So the bartender is just going to look the same as the blocking case. The same for the entity, we just use our normal Panache entity. We have our simple repository again, all the same. The only thing we do is put on an annotation, run on virtual thread. So in Spring, you would put it in your entire application config. Here, you would just put it on a resource or on a method, as if you say only this method can be done on a virtual thread. So you explicitly opt in per use case. That's to come back to what you mentioned earlier. Instead of enabling it for everything, here you can be a bit more deliberate. So like, hey, I know for sure those things are safe to run on a virtual thread or make sense to run on a virtual thread. You can enable it. And there are some discussions going on. Should we make this a default, yes or no? Then the simple get beverage. Well, that's going to be an easy one. And here we see, indeed, it got handled by virtual thread 0. And in this case, it has a name. If we want to do the sequential, we can just do it in sequential. Nothing special needed. So I'm going to skip this. If we want to do this in parallel, we're going to use an executor. But this is going to be a special executor. The one that we inject now is going to be a virtual threads executor service. Yeah, because by default it will give you a blocking pool. And this way it will instruct the framework to give you the virtual thread pool. To give you a virtual thread instead of a platform thread. And I think in Spring you can do the same, create a bean that does the same. Jakarta EE, you can specify in an annotation as well to get a virtual thread in this case. So here we submit them again. So we do in parallel. So what we see now, the request was received on virtual thread 1. Then the executor service is going to give us a virtual thread per task that we spawn. So we get virtual thread 2, 3, and 4. And then in the end, it all comes together on virtual thread 1. So it comes back on virtual thread, it joins it, gives it back to the user. Well, there are some other things you can do in this thread factory. Instead of injecting the executor service, I can get the current thread name. This is going to be a virtual thread. Then have my own builder here where I specify some things I want myself. So you still have this builder API here as well if you want to explicitly have something. So if I now do the custom one. So now I decide the naming myself, right? So the framework receives it on Quarkus virtual thread 5, but I spawn these threads myself instead of the framework doing this through the executor service. So I'm really in control myself that I can spawn them myself per task. All right, let's go back to the slides. So with virtual threads, you just slap on the annotation or in Spring enable in the config, you're done. You don't have to do anything. So we're going to see some different options. We have Kotlin coroutines. They've been around for quite some time now. And indeed here, you need to annotate all your functions or put the suspend keyword all over the place. So if you have all those things, the fetch user is async, so we put a suspend there. Then the other function calling my fetch user, fetch orders, also has to have the suspend keyword. So you will scatter all around the frame, your application all those suspend keywords. And with virtual threads, you don't really have to do this because with the stackful approach that we have here. They're lighter than threads. They run on a dispatcher, but we're not going to go into the low-level details of coroutines. But it's basically the compiler transforming suspend function in a state machine and dispatching that for you. And they have a coroutine scope. So these variables live only for that scope of the coroutine. So that's how we can have scope values in Kotlin as well. The nice thing is, here you have structured concurrency built in from day one. Let's skip over this one. If we don't gonna have a look at structured concurrency, is the missing link. So what problems does structured concurrency solve? We can have thread leaks from forgotten subtasks, so tasks are spawned somewhere and we forgot to cancel them. We don't really have a good semantics for canceling tasks across tasks. The error handling is ad hoc and often wrong, and no clear parent-child relationships in thread dumps. So that's what you mentioned as well. It's really hard to figure out which thread runs when, and this gives us a bit better hierarchy. So here we can have a structured task scope who owns a set of subtasks. So this looks a lot like the Kotlin version, where we open a structured task scope and we give it a joiner. So that's what we saw in Mutiny as well, where we give it a joiner, so like all successful, or you can also do some eager. It has some default options, but you can also implement your own joiner if you would want to. Then we would fork that scope, so you can see create some subtasks in there, so that those tasks get the same scope. Then you join back that scope, and then you can give back the results. I would love to use this in production, but please don't run with --preview in production. Test this on your apps, test it in dev mode or in test somewhere, but don't put this in production yet. It will probably work, but it's still in preview, so yeah, if your production breaks down because of the preview feature, you shouldn't want that. So it has been incubated at the same time as virtual threads were in preview, and they've been iterating over and over again. And the API, the public API, keeps on changing ever slightly. So they don't do big changes, but for example, in JDK 25, they added some static factories. You had the joiner API, so you could implement your own joiner, so your own strategy for fail fast or collect failures. Then in preview 6, we had the on timeout. And now in preview 7 that I tried out this weekend, you can have checked exceptions again from your join method. So you see step by step, they're tweaking it before giving it to the public. But you're welcome to try it out and give them some feedback as well. So if we have a look at that example, so nothing's going to be different here. Let's jump to the interesting bits. So we still say receive the request on a virtual thread, so the framework will handle the request on a virtual thread. And here you can see it in action. So now we're going to open a scope. So this is a bit like the uni combine all. There we give it a strategy, and it has a default strategy. So if we look at this builder here, the default strategy is await all successful or throw. So it's going to wait for all the tasks to come back, and if one fails, it's going to throw you an exception. And here, now this API has been changing, so every time I had to adjust my demo a bit for every JEP, because the API will be slightly different. And here you can now safely call say .get, because this all runs on a virtual thread. So even the .get is not blocking. We can safely do a .get here, because, well, we don't block the world, so we can just safely call get again on the future. Let's see that in action, examples. And here you see it in action. So the framework handled the request on Quarkus Virtual Thread 6. Then we spawned some virtual threads. They don't have a name anymore because the JVM created them for us. So it doesn't care about giving them a name. And then it joins back here on number 6 again. If we then do a custom solution, well, again, we can implement our own thread factory, give them a proper name. Then we can give our own joiner. So here we can implement our own joiner if we want to, and specify the thread factory. The nice thing is, if you make a type like this, so if I type my joiner, now the JVM now is the result of a joiner. Otherwise, above the, if we see above here, it would be just something called object. So it didn't know the type. But if you give it a type hint here, hey, all your subtasks are going to be your type of beverage. Then I can directly do scope.join, and I get a list of beverages. So you don't have to do all the .get, because yeah, the library under the hood does all that work for you. And that's one of the examples that changed as well. That wasn't there before, where you really had to do it explicitly. Now you call .join, and it knows the type, and you get back a list of results. Yeah, so I think that was in the latest JEP, where they added another type argument with the, so you can have a typed exception of your own that you can return back yourself. So you can have a domain-specific exception for that case as well. So that's another good example after some feedback to incorporate those things as well. All right, let's see. Let's skip the other examples. So we saw a whole bunch of examples. We're mainly using Quarkus, and in Quarkus we can combine imperative, reactive, and virtual threads. We can do all of that at the same time, even in the same controller. We can just mix and match whatever we want. With Spring Boot, it's going to be blocking by default, but as mentioned before, you can just enable virtual threads via one-line config. It's a bit dangerous because, well, maybe some of your code is not really suitable, but now that the pinning has been fixed, I think for most CRUD enterprise applications, should be safe to enable. Test it in your test environment, but then you should be good to go. Then you Spring Web Flux. It's still reactor-based, but you see a lot of people moving away from that. Especially now, though, yeah, we have Spring Boot with virtual threads, so people are slowly discarding Web Flux. Then we have Helidon. Helidon 4 was fully rebuilt on virtual threads. So it doesn't use Netty under the hood anymore, but it was really fully rebuilt on virtual threads. It's one by the Oracle team. Micronaut, you can do both as well. And in Vertex, the low-level Vertex, you can also have virtual thread verticals. So basically every major framework supports it. And I think Helidon even took the extreme, they rewrote it fully, got rid of Netty, and do it fully virtual thread-based. So if you do still want to use Webflux, if you do streaming data, server-side events, reactive pipelines, if you need explicit back pressure, then those systems still have a valid point, right, if you're doing Spring. Or if you're building edge gateways where you have high fan-out, then it's useful. Or you just have a team that's really proficient at writing Webflux code, why not? Then you can still keep it, it will perform greatly. Well, that's what I mentioned as well. Let's skip that. Yeah, so this is what I like the best in Quarkus. You can actually have all three paradigms at the same time and in your same controller even. You have even more fine-grained control where you can slap, even if the type is a uni, you can still slap on blocking, and Quarkus will handle it still as a blocking goal, even if somewhere is a uni. So you can really mix and match, but for your modern CRUD endpoints, you should probably just use a virtual thread. Then people ask me, what about performance? Do virtual threads really provide you better performance? And again, as an IT, it depends. I don't have a straightforward answer. I wanted to do some performance testing myself, but then I was like, no, measuring performance is way too hard. The Quarkus team also did an episode on this. Building a benchmark is easy, but building a good benchmark is really, really hard. So they have a performance lab at IBM Red Hat where they do this. Yeah, to do this is really complex to get reproducible results. If I would, for example, do this on my MacBook, you get throttling of the heat. I have Slack running in the background. Is going to make a disaster of your benchmarks. So they did it the proper way. This is official numbers they publish on the website as well. So you can say Quarkus is already ridiculously fast. So it's already super fast compared to the same workload on Spring. Then what about Loom? What are the numbers for Loom? Well, those numbers are a bit iffy. They do publish them, so I didn't put them in the presentation, but you can view them online. But every time they do some performance test or they tune something, those numbers really go up and down. So I saw some slides where it was really a lot faster, sometimes a bit slower. So they're really tweaking the performance benchmarks as well to see like, hey, how do we properly benchmark this even? So if I open my other screen. So this is the benchmark I showed you. Here you can see all the numbers. And here you can see that if we enable virtual threads in Quarkus, it might be slightly slower. Spring does benefit a whole lot. Still not faster than Quarkus, but benefits a whole lot. So that's why they have the toggle, just enable them, because, well, you gain 3 times the performance apparently in certain workloads. But with Quarkus, it's always a bit, yeah, does it really provide us more performance? Because because of these event loop threads under the hood with Vertex and Netty, they were already ridiculously fast and optimized. And then virtual threads are always a bit around, sometimes a bit slower, sometimes a bit faster. So some other things that they're working on, I can show that here. Franz from IBM did a nice presentation. You should really check it out if you want to go more low level, learn about context switches. But the biggest problem is that there's too many context switches happening. So if we have with Quarkus event loops, they were pretty heavily optimized for not doing too many context switches. But because the virtual threads uses its own scheduler, you're going to have too many context switches. So then in certain workloads, it's going to be slower and a lower throughput. So what he was a custom scheduler. Right now on the main branch, you can't implement a custom scheduler. You really have to grab this special Loom build, which exposes a custom scheduler as an API. And then you can do better. So he's experimenting, can we implement a better scheduler, and giving feedback to the Oracle team in how they could optimize the scheduling of virtual threads, especially with I/O threads. And there, especially those numbers are crazy, right? The reduction in context switches, that really hits you in the performance. So he tries to really reduce the number of context switches. But this is all work in progress. There's more to show you. There's more behind the scenes. And if you want to watch that talk, I really liked it a lot. So it gives you a bit more details about the internals of virtual threads, of the schedulers, etc. And it's Francesco Negro doing that. Then, we're going to finish a bit early today because we already saw some beers outside. And I think it has been a long day already for everyone. So let's not stay the full 2 hours here today. Before you go home, we have a few charts. So if we look at the programming model, the blocking code gives us imperative code. Then reactive gives us this async operator chains. And then with virtual threads, we got imperative code back. What will be the throughput ceiling of blocking apps? The thread pool size. I just don't have more CPU or memory to spawn more threads. In reactive, it will be really CPU and I/O bound. And the same is true for combined, but for a single endpoint, it should be non-blocking all the way. Virtual threads, well, we had a limitation, do not pin them, but that's okay in modern JVM, so you can forget about the entire pinning story mostly as well. So, one does blocking shine. If you just have a small back office app, your enterprise CRUD app, why bother rewriting it? A blocking app will just work fine, has been working fine forever. Why bother changing it? You could enable virtual threads if you want to, but yeah, it's not, if you don't have a high throughput anyway, why bother? Operated pool under high load, that's what we discussed earlier today as well. Reactive, mixed paradigm teams. If your other half of the team or your other team doesn't do reactive, how are they going to maintain your application and vice versa? So now they're going to have complex flows to debug, etc. And virtual threads, don't fix your CPU heavy work. It doesn't make magically your application faster. That's what a lot of people thought, like, well, just enable virtual threads, gonna make it faster. It's not gonna fix that, but we all know that now. So, again, pick blocking for your simple apps. Pick reactive when you have edge gateways with high fan-out aggregations, for example. When you have a lot of microservices, maybe edge gateway where you need a lot of control and high fan-out. Makes sense to do that one reactive, but then maybe the downstream services could just use virtual threads. And then pick structured concurrency. Once it's final, don't enable a preview in production. Then there's a whole lot of reading, a whole lot of JEPs, a whole lot of documentation I reference here as well. You don't have to remember them because you can just scan the QR code. And then we're done for today. Any questions so far you want to discuss or ask?
Oh.
That's for the recording,
One,
so
two,
they hear
three.
you online as well.
Oh, thank you. Do you understand correctly that virtual threads really helps us to save processor time somehow, but it doesn't help us to use memory more effective?
It should also use memory more effective, yes.
Also.
Yes, because you only need a handful of threads called carrier threads, and those are platform threads in the end as well. Opposed when you have an entire pool of like 200 or 500 worker thread pools, they need 500 times that amount of memory. So you only need a bunch of platform threads. You only use that tiny amount of memory instead of spawning a couple of hundred. So it is also more memory efficient.
Really more efficient than simple. Okay.
Thanks. Any more questions? Yeah, pass it along.
So for the final conclusion, is it worth it to learn or to implement reactive programming?
So then I will go back to this slide. It depends. Probably for your normal CRUD app or enterprise app, probably no. Don't adopt it. But if you're doing streaming use cases, edge gateways with where you need high throughput, then you could use it, yes. But most people that I know don't really do that scale. So then keep it simple. Any more? Oh, can you use the microphone for the recording?
What do you think about async, single-threaded?
Could you elaborate on that? How would you?
Because you said blocking, you mix like blocking with single-threaded.
Yeah.
There are threads which can be async and still single-threaded. For example, a lot of runtimes like let me give which example I can give you. lipuv, for example. It is a single-threaded event loop that is async. It is used by Node.js and all of those types of frameworks.
Yeah.
And they offer a disk concurrency model, which is single-threaded async. And I thought that maybe it should get its place here on its list because
I didn't really consider it indeed, but it's a good suggestion to maybe look broader than the JVM ecosystem, indeed what the other systems do and what we can learn from those.
For example, in my high-frequency trading days, guys, everyone will hear. I don't care about the stream anyway. So what I meant is in high-frequency trading, people usually structure their applications. You have single threads, and then you have a lockless queue.
Mm-hmm.
Those consumers, you also split them between publishers and consumers, but every consumer is a single-threaded thing that is pinned to a CPU.
Mm-hmm.
And this way you don't get context switching or all of those things. And for example, a lot of high-performance databases use this, for example, SkillaDB. And maybe it is something that is worth exploring for you.
Yeah, definitely a good suggestion. I think it will be a nice addition to this overview as well, and also in the beginning to give some more context. So, some more homework. Thanks. All right, then I wish you a nice evening and a nice day tomorrow as well at the conference. Thanks.